Hi friends, my name is Maruti and I am the co-founder of Kraku. In this video, we'll be looking at the algebra questions that were asked from CAT 2017 to CAT 2022. There will be around 80 to 85 questions in this video. Please pause the video when the question is shown and try to answer it on your own, and after that look at the video solution. Algebra is a very important topic for CAT and I hope that this video will be very useful for you. As CAT is approaching, many students ask me what is the best way to use the last few days for CAT. These last few days are very crucial for you. If you are looking to make the best use of these last few days, try to take as many mocks as you can. Kraku's dash CATs are expected to be very similar to the actual examination. We put in a lot of effort to ensure that the mock difficulty level is similar to what is expected in CAT, be it verbal or quant or LRDA. Thousands of students take these mocks and I hope that they will be very useful for you. If you are enrolled to the Kraku dash CATs, definitely take them. If you don't have time to take all the dash CATs, at least take the first 5 dash CATs. At least 5 to 10 mocks from dash CATs should be taken by every serious aspirant for CAT. We are also providing a lot of free stuff. All the questions that you see today are from the previous year's papers for CAT, and you can download all the PDFs for free on our Kraku website. You can actually download the previous papers for CAT, ZAT, SNAP, CMAT, all the important MBA examinations for free. The PDFs are available on our website. Make the best use of it and put in the hard work. Whatever hard work you're putting in now will definitely help you on the day of the examination.
In this question, it is given that a and b are integers of opposite signs such that a plus 3 whole square by b square is equal to 9:1 and a minus 1 whole square by b minus 1 whole square is 4:1. We are required to find out the ratio of a square by b square. So let us try to solve both the equations and see what we will get. If you are looking only at the first equation, it implies that a plus 3 whole square by b square is equal to 9. We can take square roots on both sides. So a plus 3 by b is equal to plus or minus 3, or a plus 3 is equal to 3b, or a plus 3 is equal to minus 3b. Now let us look at the second equation. It says that a minus 1 whole square by b minus 1 whole square is equal to 4 by 1, or a minus 1 is equal to plus or minus 2 into b minus 1. Again we are going to get two equations, that is a minus 1 is equal to 2b minus 2, or a minus 1 is equal to 2 minus 2b. We can simplify this. So a is equal to 2b minus 1, or a is equal to 3 minus 2b. So now we have basically four equations. There are four possibilities and we will solve for all the four possibilities, try to find out the values of a and b, and we should have both of them as integers with opposite signs. Then we will pick those numbers and try to calculate the value of a square by b square. So the first case is a plus 3 is equal to 3b and a is equal to 2b minus 1. This is the first case, that is when these two are correct. The second one is a plus 3 is equal to 3b and a is equal to 3 minus 2b. This is the second case, that is when these two hold true. The next one will be a plus 3 is equal to minus 3b and a is equal to 2b minus 1. That is when these two are correct. And the last case is a plus 3 is equal to minus 3b and a is equal to 3 minus 2b. So here we have four possibilities. We will solve for a and b in each one of them and then try to move forward. So if we are solving for these two, we can substitute the value of a in the first equation. So we are going to get 2b minus 1 plus 3 is equal to 3b, or the value of b is equal to 2. So the value of a, which is equal to 2 into 2b minus 1, will equal 3. So this is one solution, that is b is equal to 2 and a is equal to 3. Although both of them are integers, they are of the same sign, both of them are positive. So this is not the correct answer. If you are looking at the second one, again we will substitute the value of a in the first equation. So we are going to get 3 minus 2b plus 3 is equal to 3b, or 5b is equal to 6, or b is equal to 6 by 5. This is also not correct because in this case b is not an integer. We can calculate the value of a, but that is not needed. If we are looking at the third one, again we will substitute the value of a in the first equation. So we are going to get 2b minus 1 plus 3 is equal to minus 3b, or 5b is equal to minus 2, or b is equal to minus 2 by 5. Again this is not the correct answer because b is not an integer. Now let us look at the last option. We will again substitute the value of a in the first equation. So it is 3 minus 2b plus 3 is equal to minus 3b, or minus b is equal to 6 or b is equal to minus 6. If b is equal to minus 6, a, which equals 3 minus 2b, will be 3 minus of minus 12, so that is equal to 15. So in this case, a is 15 and b is minus 6. Both of them are integers and both of them are of the opposite sign. So this is a valid solution. So now let us try to calculate the value of a square by b square. A square will be 15 square by b square will be 6 square. Both of them are multiples of 3, that is 15 and 6. So we can simplify this as 5 square by 2 square. This is equal to 25 by 4. So the answer in this case is 25 by 4. In this question it is given that x plus 1 is equal to x square and we are required to find out the value of 2x to the power 4. So we are told that x square is equal to x plus 1, and as we are required to find out the value of 2 into x to the power 4, one way to look at it is this is a quadratic equation. We can solve the quadratic equation and find out the value of x. Once you have x, you can raise it to the power of 4 and find the value. But there is a simpler way in which we can do it. As x square is equal to x plus 1, when you square both the sides, x to the power 4 is equal to x plus 1 whole square. This is equal to x square plus x plus 1, x square plus 2x plus 1. But we know that x square is already equal to x plus 1. So this is equal to x plus 1 plus 2x plus 1. So this is equal to 3x plus 2. So x to the power 4 is equal to 3x plus 2, or 2x to the power 4, which is what we are required to find out, is equal to 6x plus 4. Now let us solve the quadratic equation and then we can just multiply it by 6 and find the answer. So as x square is equal to x plus 1, x square minus x minus 1 is equal to 0, or x is equal to 1 plus or minus square root of b square is 1 plus 4 by 2. This is equal to 1 plus or minus root 5 by 2. But we are told that x is greater than 0. So 1 minus root 5 by 2 is not valid. So the value of x will be 1 plus root 5 by 2. Now as we have discussed earlier, to find out the value of 2 into x to the power 4, we need not raise this to the power of 4. We have already found out that 2x to the power 4 is equal to 6x plus 4. So we can just simply multiply this with 6. So 6x equals 3 into root 5 plus 1. And when you are adding 4 on both sides, we are going to get 3 root 5 plus 7. So the answer in this case is option D, 3 root 5 plus 7. In this question, we are required to find out the number of solutions of the given equation x minus y minus z is equal to 25, where x, y and z are positive integers, that is, they are natural numbers, such that x is less than or equal to 40, y is less than or equal to 12, and z is less than or equal to 12. So let us first try to enumerate it. Let us first find out the number of solutions when x is exactly equal to 40. This is the higher bound for x. So when x is equal to 40, it would imply that y plus z is equal to 15, because x minus y minus z is equal to 25. We know that y and z are natural numbers, that is, they are positive integers less than 12. So the possible values for y are 3, 4, 5, ... till 12. Notice that y cannot be 2, because in that case z will be 13, which is more than the upper bound, and y cannot exceed 12, because that is the highest possible value for y. So the number of solutions for this is 1, 2, 3, ... till 10. So when x is equal to 40, the number of solutions for this equation is 10. Similarly, let us calculate it for x is equal to 39. In this case, y plus z equals 14, and y can equal 2, 3, 4 and up to 12. Notice that in this case y can be 2, because z will be 12 in that, and 12 is the highest possible value. So in this case, the number of possible solutions for the equation is 11. Let us calculate it for x is equal to 38. Then y plus z is equal to 13, and the possible values of y are 1, 2, 3 till 12. So all the possible values from 1 to 12 are allowed. In this case, the total number of solutions for the equation is 12. Now notice that when x becomes 37, y plus z is equal to 12, and here y can go from 1 to, it can go only up to 11. Because the moment y becomes 12, z has to equal 0, but that is not possible because all of them are positive integers. So the number of possible solutions is 11. We can continue further and you can then notice a pattern. When x becomes 36, y plus z will equal 11. So the possible values of y vary from 1 to dot 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 till only 10 here. So the number of possible solutions is 10. And as you keep decreasing x, the number of possible solutions also keep decreasing by 1. For example, in the case when x is equal to 26, x cannot equal 26. Suppose x is equal to 28. Then y plus z is equal to 3. So the possible values of y will be only 1 or 2. Then the number of possibilities is only 2. And when x is equal to 27, which is the least possible value for x, y plus z will equal 2 and y has to equal 1. In this case, z will also have to equal 1, and that is the minimum possible value for both y and z. So in this case, the total number of possible solutions is 1. So if you are trying to calculate the total possible solutions for the equation, it has to be 10 plus 11 plus 12 plus 11 plus 10 plus 9 dot 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 till 1. Now we know the summation of 1 to 12. The summation for any natural number, the sum of all the natural numbers which are less than or equal to a particular number n, we have the formula, that is 1 plus 2 plus dot 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 till n is equal to n into n plus 1 by 2. So in this case, 1 plus 2 plus 3 plus dot 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 till 12 will equal 12 into 13 by 2, which is equal to 13 into 6, which is 78, and 10 plus 11 is 21. So the total number of solutions is 78 plus 21, which is equal to 99. So the answer in this case is 99. In this question, we are required to find out the number of integers n for which the inequality n minus 5 into n minus 10 minus 3 into n minus 2 is less than or equal to 0 is satisfied. So let us first simplify the given inequality. So this will be n square minus 5n minus 10n plus 50 minus 3n plus 6 is less than or equal to 0. Or this is n square minus 5, 10 and 3 is 18n plus 56 is less than or equal to 0. We can easily factorize this. We can factorize this into two roots such that the sum of the two roots is minus 18 and the product is 56. If you think about it, both of them are minus 14 and minus 4. So you can expand this as n square minus 14n minus 4n plus 56 is less than or equal to 0. Or n into n minus 14 minus 4 into n minus 14 is less than or equal to 0, or n minus 4 into n minus 14 is less than or equal to 0. Once you have an inequality of this form, it is very easy to find out the values of n which satisfy this inequality. The values of n which satisfy this inequality will lie between 4 and 14. Both of them are included. Why is this the case? Because if n is less than 4, then n minus 4 will be negative and n minus 14 will be negative. So both of them will be negative and their product will be greater than 0. n minus 4 into n minus 14 will be greater than 0 because this is negative and this is negative. When n is equal to 4, n minus 4 will equal 0. So n minus 4 into n minus 14 will exactly equal 0. When n lies between 4 and 14, n minus 4 is positive and n minus 14 is negative. So their product will be less than 0. And when n is equal to 14, again n minus 14 will be 0 and the product n minus 4 into n minus 14 will be is equal to 0. And when n is greater than 14, both of them, that is n minus 4 is positive and n minus 14 is positive. So their product will be greater than 0. So when we are looking for the integers for which n minus 4 into n minus 14 is less than or equal to 0, the required integers will lie between 4 and 14, both of them included. So they will be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So the total number is 11 such integers exist. In this question you are given two functions, f of 1 is equal to x square plus 11x plus n and f of 2 is equal to x, and we are required to find out the largest positive integer n such that the equation f of 1x is equal to f of 2x has two distinct real roots. So let us first write down the equation f of 1x is equal to f of 2x and see what it represents. So whenever f of 1x is equal to f of 2x, x square plus 11x plus n is equal to x, or x square plus 10x plus n is equal to 0. This is a quadratic equation. Now we know that a quadratic equation of the form ax square plus bx plus c is equal to 0. This will have two real and distinct roots whenever the discriminant d is greater than 0. Now what is the value of the discriminant? This is b square minus 4ac. Now b is the coefficient of x, a is the coefficient of x square and c is the constant term. So this quadratic equation x square plus 10x plus n will have two distinct real roots whenever the discriminant is greater than 0. What is the discriminant? It is b square, that is 10 square, minus 4 into a, the value of a is 1, into c, c is n. This is greater than 0, or 100 is greater than 4n, or n is less than 25. We are told that n is a positive integer. So the maximum possible value of n will be 24 for f of 1 equal to f of 2x to have two distinct real roots.
So this is one of those things where people often assume that functions questions are on the harder side and then they don't attempt it. But as you can see from this particular question, they are actually pretty easy if you just give them a try. So let's take a look at the question. If f of x is equal to 5x plus 2 divided by 3x minus 5 and g of x is x square minus 2x minus 1, then find out the value of g of f of 3. Now, as you can see, we have been given what is f of x and what is g of x. So, and we have been asked to find what is g of f of 3. Here you don't need to remember any concept as such. You just need to substitute values. That's as simple as it gets. So, what is f of 3? If I substitute 3 in this particular equation, I get 15 plus 2, that is 17, and that is 9 minus 5, that is 4. So, I get f of 3 as 17 by 4. Now what is f of 3? I substitute f of, that is essentially f of 17 by 4. Now I substitute 17 by 4 in the given equation. I get this value as 5 times 17 by 4, that is 85 by 4 minus plus 2 divided by 3 times, that is 51 by 4 minus 5. So this is essentially 93 by 4. And this is 51 minus 21, that is 31 by 4. So 4 cancels, 93 by 31, that is equal to 3. So f of 3 is essentially 3. So what is g of f of 3? This is essentially g of 3. And if I substitute 3 in this equation, I get 3 square minus 2 into 3 minus 1, that is 9 minus 6 minus 1. So this is equal to 2. So as you could see, this was a pretty easy question. It just looked intimidating on the first reading. The answer to this question is 2. So always make sure that you at least think through the question before you skip the question. As you can see, some questions are deceptively hard, like this question.
In this question it is given that f of x is equal to x square and g of x is equal to 2 to the power x for all real x. We are required to find out the value of f of g of x plus g of f of x at x is equal to 1. So what we are required to find out is f of g of x plus g of f of x when x is equal to 1. When x is equal to 1, f of 1 is equal to 1 square, which is 1, and g of 1 is equal to 2 to the power 1, which is equal to 2. So what we are required to find out is f of f of g of x is f of 2 plus g of f of 1 is g of 1. Now f of 2 will equal 2 square, which is equal to 4. Therefore, this becomes f of 4 plus g of 1 is already calculated, it is equal to 2. So this is equal to f of 6, which is equal to 36. So the answer in this case is 36. In this question, we are given a quadratic equation x square plus a plus 3 into x minus a plus 5 is equal to 0, and we are required to find out the minimum possible value of the sum of the squares of this quadratic equation. Now notice that we don't know the value of a. A is a variable, but it will vary such that we want to minimize the sum of the squares. So let us assume that the roots of the equation are alpha and beta. By the properties of quadratic equations, we know that alpha plus beta is equal to a plus 3 minus of a plus 3. Remember that if there is a quadratic equation ax square plus bx plus c is equal to 0, the sum of the roots is equal to minus b by a, and the product of the roots is equal to c by a. When the given equation is x square plus a plus 3x minus of a plus 5 is equal to 0, a is the coefficient of x square. So in this formula, a will equal 1, b will equal minus of a plus 3, b will equal a plus 3, b is the coefficient of x, and c is the constant term, this will equal minus of a plus 5. So the sum of the roots, which is alpha plus beta, is minus b by a. In this case, that will equal minus of a plus 3, and the product of the roots equals alpha into beta, which is c by a. Now c is minus a by 5 and a is 1, so the product of the roots is minus of a plus 5. What we are required to find out is minimizing the sum of the squares, that is, we need to minimize alpha square plus beta square. But alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha beta. Now alpha plus beta whole square will be a plus 3 whole square, and minus of 2 alpha beta will be minus of 2 into minus of a plus 5. So this will be minus of 2 into minus a plus 5. So here we can cancel both the negatives, negative into negative is positive. So this will equal a square plus 6a plus 9 plus 2a plus 10, or this will equal a square plus 8a plus 19. This is the expression that we have to minimize. Now we can easily complete the squares. You know that the coefficient of a is 8, so we can complete the square by making this 8 by 4 whole square, a plus 8 by 2 whole square. So this will be a square plus 8a plus 16 plus 3. 8 square plus 8a plus 16 is a plus 4 whole square plus 3. Now we know that a plus 4 whole square cannot be negative. So the minimum value of the sum of the squares is 3, which happens when a is equal to minus 4. So the minimum possible value of the sum of the squares is 3.
This is a question from number systems. So let's take a look at the question. How many different pairs a comma b of positive integers are there such that a is greater than or equal to b and 1 by a plus 1 by b is equal to 1 by 9. So let's start with the equation first. We have 1 by a plus 1 by b is equal to 1 by 9. So we can write this equation as a plus b by ab is equal to 1 by 9, or ab is equal to 9 times a plus b. We can take this term on the LHS, so I can write this as ab minus 9 times a plus b is equal to 0. Now I've been given some extra information. I've been told that a and b are positive integers and a is greater than or equal to b. Now if these are positive integers, I can express them, if I can find a way in which I can express them as a multiplication of two numbers, then I can factorize the constant that I get on the RHS and then find pairs of a and b that satisfies those I can factorize the constant on the RHS and find pairs A and B that satisfied that kind of a relationship. So I basically have to change this equation into an equation such that x minus A into x minus B is equal to some constant. So if I can change this equation to this format, then I can write down all the factors of k, and then I can say that if these are all the factors of k, that means x minus A is equal to this factor and x minus B is equal to this factor. Also, since we have the relationship between A and B, for each factor of k, I will get one pair A and B. So that is my end goal. So let's see how I can change this equation to this equation. So I can write this as AB minus 9 times A plus B is equal to 0, or I can write this as AB minus 9A minus 9B. I'll add a constant value k to both LHS and RHS. Now I can write this as A times B minus 9. Now I should be able to get the same factor out of the second part also. So my k should be such that if I take minus 9 in common, I get B minus 9 in over here. So this should be essentially minus 9 into minus 9. Therefore k should be 81. So I'll write plus 81 on both LHS and RHS. So by taking minus 9 in common, I say minus 9 B minus 9 is equal to 81. So I can write this equation as A minus 9 times B minus 9 is equal to 81. Now as I said, I've gotten it in the required form. Now I can write factor is 81 and then say for each factor of 81, A will take a particular value and B will take a particular value. Now the product of these two numbers is positive. So two cases exist, that is, first case is both A minus 9 is greater than 0 and B minus 9 is greater than 0, or the second case is A minus 9 is less than 0 and B minus 9 is less than 0. Now let's first take the following case where A minus 9 is greater than 0 and B minus 9 is greater than 0. If that is the case, then I can say that this is the multiplication of two factors that gives me 81. So what are all the factors of 81? That is 1 into 81, 3 into 27 and 9 into 9. Since it is A minus 9 and B minus 9 and A is greater than or equal to B, that means A will be the bigger factor of the two. So all of these values A will take and correspondingly B will take these values. Therefore, the values of the pairs A comma B such that A minus 9 into B minus 9 is equal to 81 is, so A minus 9 is 9, A minus 9 is 9 and B minus 9 is 9. So A is equal to 18 and B is equal to 18. A minus 9 is equal to 27, so A is equal to 36 and B minus 9 is equal to 3, so B is equal to 12. A minus 9 is equal to 81, so A is equal to 81 plus 9, that is 90. B minus 9 is equal to 1, so B is equal to 10. I hope you understood why I chose the smaller number as B. It's been given that A is greater than or equal to B, and since A and B are positive integers, therefore A minus 9 should be greater than B minus 9. Therefore A minus 9 will take the bigger factor and B minus 9 will be the smaller factor. By assuming that, you get these three pairs, that is 18, 18, 36, 12 and 90, 10. So in this case where both are positive, this is case 1, I get 3 pairs. Now let's consider the case 2 where both are negative. Now this means that A is less than 9 and B is less than 9. And both are positive integers. So this is greater than 0 and this is greater than 0. There are no two values A and B, positive integers, which are less than 9, such that their product will be equal to 81. So there is no case which satisfies this given equation. So clearly this value like A minus 9, if A is in this range, A minus 9 will actually be in a range again. It will be in minus, if it is the, it will be in the range minus 9, A minus 9 to 0. Similarly, B minus 9 will also be in this range, B minus 9 to 0. Their product will never be equal to 81. So given this fact that this will be in this range and if the product will not be equal to 81, this yields 0 cases. Therefore, the total number of cases are these 3 cases. So there are 3 different pairs that of positive integers such that a is greater than or equal to b, and 1 by a plus 1 by b is equal to 1 by 9. So the answer to this question is 3.
In this question, you are told that f of a into b is equal to f of a into f of b for all positive integers a and b. Then we are required to find out the largest possible value of f of 1. Now f of 1 is equal to f of 1 into 1, because 1 into 1 equals 1. But by the definition of f of ab, this will transform itself into f of 1 into f of 1. Now if you are assuming that f of 1 is equal to a, the given equation is represented by a is equal to a into a, which is equal to a square. Therefore a square minus a is equal to 0, or a into a minus 1 is equal to 0. Therefore a is either equal to 0 or is equal to 1. So the largest possible value of f of 1 is equal to 1. So the answer in this case is 1.
Google search Krakow free cat mock. Click on the first link. You can attempt a free mock test which was attempted by 30,000 cat aspirants in the actual exam format. After completing the test, you get detailed solutions, analysis and percentile along with your scorecard to gauge your All India performance. Click on the solution to get video solutions from our expert faculty.
Let f of x be equal to 2x minus 5 and g of x be 7 minus 2x. Then f of x plus g of x, the modulus of whole of that, is equal to modulus of f of x plus modulus of g of x if and only if, and 4 options are given. So this is a question on functions. Generally you can expect 2 questions from functions in CAT, and they tended to be on the tougher side. So let's take a look at this question as such. So we are given like an equation with modulus in it. So essentially when you have modulus of any term as such, you have to split up the cases where something is valid. Now in this case, we will consider the 2 cases where f of x is greater than or equal to 0 and g of x is greater than or equal to 0. Let this be case 1. When this is true, then f of x plus g of x, the whole of modulus of that will be equal to modulus of f of x plus modulus of g of x, because in all of these cases, all of these values will be greater than or equal to 0. So in this case, this will be equal to true. Now suppose f of x is greater than 0 and g of x is less than 0. If f of x is greater than 0 and g of x is less than 0, in that case f of x plus g of x will be different. In this case, if g of x is less than 0, then the negative amount will be invalidated by the modulus. So this will essentially become f of x minus g of x, and this side will be unaffected. Now suppose f of x is less than 0 and g of x is greater than 0. In that case, we get minus f of x plus g of x. So even in this case, this is not valid. And the last case is when both are less than 0. When both are less than 0, this will be minus f of x minus g of x. The minus sign will get cancelled, and this will be minus f of x minus g of x. So even in this case, the second case, when both are less than 0, even in that case, less than or equal to 0, even in that case, both of this inequality will hold. The only time they will not, this expression will not, this equation will not be true is when one of them is positive and the other one is negative. Because when one of them is positive and the other one negative, then this expression g of plus g of x will not be carried over here, where this would then instead be replaced by minus of g of x, or we will have minus f of x plus g of x. So because of that, this expression will hold only when both have the same signs. Either both are positive or both are negative. Now let's consider the first case where both are positive. Now if both are positive, then we can say that f of x is 2x minus 5 is greater than or equal to 0 and 7 minus 2x is greater than or equal to 0. So x must be greater than or equal to 5 by 2 and x must be less than or equal to 7 by 2. So x must be essentially between 5 by 2 to 7 by 2. So this is the first region. Now f of x is less than 0 and g of x is less than 0. Then 2x minus 5 is less than equal to 0 and 7 minus 2x is less than or equal to 0. So x is less than or equal to 5 by 2 or x is greater than or equal to 7 by 2. But this can't happen simultaneously. X can't be less than 5 by 2 at the same time be greater than 7 by 2. So this yields no region. So the only region is when x is between the range 5 by 2 to 7 by 2 and this is less than or equal to sign. Therefore the right answer is option D. There is another alternative way in which you could have solved this question without having to calculate all of this. That is by looking at the options directly. So how do you do that? So you are asked when is this true? So you can just consider the different cases and substitute values of x from that particular regions. Now suppose if I assume x is 0. So x is 0 would be valid according to options B and C. If x is 0, then f of x is minus 5 and g of x is 7. In that case, for when x is equal to f of 0 is minus 5 and g of 0 is 7. So in this case it is minus 5 plus 7, so this value will be equal to 2 and this value will be equal to 5 plus 7, so this will be 12. So f of 0 x equal to 0 definitely does not satisfy this expression. So any range which contains 0 will not be correct. So we can directly eliminate options B and C. Now between A and B, if you look at the options, both are identical ranges except instead of less than sign you have less than equal to sign. So to choose between A and D, you just have to see whether x equal to 5 by 2 actually satisfies the equation. So if x is equal to 5 by 2, f of 5 by 2, in this case it is 0 and g of 5 by 2 would be 7 minus 2 into 5 by 2, that would be 2. So f of this value would be f of x plus g of x. If you just add these two together, you see that you always get 2. So this would be 2 and the right hand side would be sum of f of modulus of f of 5 by 2 and modulus of g of 5 by 2. This again also would be 2. So f of x equal to 5 by 2 satisfies the given equation. Therefore the sign should be greater than or equal to 5 by 2. Therefore the answer should be D. So as you could see, without actually solving the entire thing, we could also pick out the right range as such. So in conditions like this, whenever you are given a range in the options as such, pick a convenient number, check whether that number solves the given equation. If it doesn't, you can directly eliminate that option and then you can be left with a lesser number of options where you can then check again which option is valid. So that is an easier way to solve questions like this.
In this question, we are given a function f of x. It is told that f of x is minimum of 2x square and 52 minus 5x, where x is any positive real number. We are required to find out the maximum possible value of f of x. So what we'll do is we'll first try to draw the graphs so that we understand what exactly has been given, and then we'll try to find out what exactly has been asked and try to solve it. So first let us draw the graph of f of x is equal to 2x square. So if you have the x and y axis, f of x is equal to 2x square will be something like this, and f of x is equal to 52 minus 5x will be something like this. It will be a negative sloped line. It will intersect the y axis at 52, 0, and it will intersect the x axis at something like 52 by 5, 0, and this is y is equal to 2x square. These are the two graphs, 2x square and 52 minus 5x, but we are only required to find out the graphs when x is a positive real number. So it will be something like this. We will only consider right side of the y axis. So again 2x square will be something like this, and 52 minus 5x will be something like this. Now we are required to find out the minimum of these two numbers. So the minimum will be 2x square as long as the intersection doesn't happen, and once both the curves intersect it will become 52 minus 5x. So the required function, which is f of x is equal to minimum of 2x square comma 52 minus 5x, will be something like this. It will be 2x square for some point, and then afterwards it will become 52 minus 5x throughout. Now this point, this curve achieves its maximum at the point of intersection of 2x square and 52 minus 5x. Now in order to calculate the maximum possible value of f of x, what we'll try to find out is, we'll first find out at what point, that is at what value of x will these two curves intersect. Once we find out the value of x, we can easily calculate the value of f of x at that point. Now these two curves intersect when 2x square is equal to 52 minus 5x. That is 2x square plus 5x minus 52 is equal to 0. We can easily factorize it, but just to make it even simpler, we notice that 2 into 52 is 104. Now the difference is 5x. So basically we need to find out two numbers whose product is 104 and who differ each other by 5. You can easily find out that those two numbers are 13 and 8, because 13 into 8 is 104 and the difference between these two is 5. So what we'll do to factorize this, 2x square plus 13x minus 8x minus 52 is equal to 0, or x into 2x plus 13 minus 4 into 2x plus 13 is equal to 0, or x minus 4 into 2x plus 13 is equal to 0. Therefore, the two curves intersect when x is equal to 4 or when x is equal to minus 13 by 2, which is minus 6.5. Of these two solutions, we can ignore x is equal to minus 6.5 because we are only concerned when x is a positive real number. But just for understanding, x is equal to 6.5 will represent the point to the left of the y-axis, at which point both the curves intersect for the first time. After that, they again intersect right of the x-axis, and this equals 4, or in this case this equals 4. So the maximum possible value of f of x occurs when x is equal to 4, and at this point f of x will be 2x square is 2 into 4 into 4, which is equal to 32. This will coincide with the second equation, which is 52 minus 5 into the value of x is 4 is equal to 32. So at this point both 2x square and 52 minus 5x are equal, and the value of f of x will equal 32. So the maximum possible value of f of x is 32. In these sort of questions, it is always important to draw the graph so that you get a sense of what exactly has been given, how the graphs look, and what we are required to find out. Once you draw the graph, for example in this case, once you understood that, all we need to do is find out at what point these two curves intersect. Solving it and finding the value as 32 is very easy. In this question, we are given a function f of x plus 2 is equal to f of x plus f of x plus 1 for all positive integers x. We are also given the value of f of 11, this is equal to 91, and f of 15 is equal to 617. We are required to find out the value of f of 10. So let us assume that the value of f of 10 is equal to b. Now we are already told that f of 11 is equal to 91. Therefore, f of 12 will equal f of 10 plus f of 11. This we know because the function was defined that way. So f of 10 is equal to b plus f of 11 is equal to 91. Similarly, f of 13 will be the sum of f of 12 and f of 11. So this will equal b plus 91, which is f of 12, plus 91, which is f of 11. So this will equal 182 plus b. Similarly, f of 14 will equal the sum of f of 13 plus f of 12. So this will be 182 plus b plus 91. So this will be 273 plus 2b. Similarly, f of 15 will equal the sum of f of 14 and f of 13. So this will equal 273 plus 2b plus 182 plus b. If you simplify, you are going to get this as 455 plus 3b. But we are already told that f of 15 is equal to 617. So this equals 617. This would imply that 3b is equal to 617 minus 455. 617 minus 455 will be 2, 162. Therefore, the value of b will be 162 by 3, which is equal to 54. So we have assumed that f of 10 is equal to b, and we are required to find out the value of f of 10. This will equal 54. In this question, we are given a quadratic equation in u and v, and we are required to find out the value of u plus 3v. So we'll first simplify the given quadratic equation, we will see how it looks, and then we will try to find out the required answer. So in this case, the quadratic equation can be simplified as u square plus u minus 2v plus 1 whole square will be u square plus 4v square plus 1 minus 4uv plus 4v minus 2u. This is the left hand side. This is equal to minus of 4uv minus 4v square on the right hand side. We can cancel 4uv on both the sides, and if we bring minus 4v square to the left hand side, it will be 2u square minus 2u plus 8v square plus 4v plus 1 is equal to 0. Now this is the new quadratic equation that we have when we simplify the given quadratic equation. But from this, there is no obvious way in which we can find out the value of u plus 3v. The only thing that we can look at it, if you look at the quadratic equation, is that the u terms are separate from the v terms. There is no common term. For example, there is no uv term. Then you should try to see if you can complete a square. That is, let us see if we can complete a square using 2u square minus 2v, and try to complete a square using 8v square plus 4v, and then try to proceed forward. Now when you are trying to simplify 2u square minus 2u, that is 2 into u square minus u, always try to remember that the coefficient of u square and in this case the coefficient of v square should be a perfect square. Over here the coefficient of u square, because you have taken 2 common, is 1. So it will be something like u minus a constant whole square. If you look at the coefficient of v, it is 1. So you should look at it that the common term has to be half, because when you expand u minus half whole square, this will be u square where the coefficient of u is matching minus 2 into half into 1. This will be the coefficient of u plus 1/4. This is basically equal to u square minus u plus 1 by 4, u minus half whole square. Therefore, the given expression, that is 2u square minus 2u, will equal 2 into u minus half whole square minus 1 by 2. Similarly, we can complete the square for 8v square plus 4v. Again, let us try to make the coefficient of v square a perfect square. So let us represent this as 2 into 4v square plus 2v. When you see 4v square as the coefficient of v square, you should look at it as this will be something like 2v plus something whole square. So the coefficient of v will be 4, and the term which is the coefficient of 2 will have already 2 into 2v, that is already there is 4v, so it will be half. The constant term will be half, because when you expand this, you are going to get this as 4v square plus 2v plus 1 by 4. Therefore, the given term, that is 8v square plus 4v, is equal to 2 into 2v plus half whole square minus 1 by 2. This is basically we are multiplying the plus 1 by 4 with 2. Now you can look at it that the given quadratic equation, that is 2u square minus 2u, is nothing but 2 into u minus half whole square minus 1 by 2, and 8v square plus 4v is again nothing but plus 2 into 2v plus half whole square minus 1 by 2, and remember that we have a plus 1 also on the left hand side. This is equal to 0. Now this minus half and plus 1 will become 0, and what we are left with is u minus half whole square plus 2v plus half whole square is equal to 0. Now this is of the form a square plus b square is equal to 0. This will happen only if a is equal to 0 and b is equal to 0, because you know that a square can never be negative. So if the sum of two squares is 0, it is possible only if both the squares are 0. Therefore, u minus half is 0, that is u is equal to half, and 2v plus half is also equal to 0. This would imply that v is equal to minus 1 by 4. Now what are we required to find out? We are required to find out the value of u plus 3v. So that will be half minus 3 into 1 by 4. This is equal to minus 1 by 4. So the required answer is option C, which is equal to minus 1 by 4. Now once you look at the quadratic equation that you get and you notice that we are required to find out u plus 3v, then you can even look at the options. All the options are constants. Once you see that there is a constant over here, you should think that because there is no common term between u and v, there is no uv term, one of the ways in which we can proceed further is by completing squares. So then you can complete squares for u and v and then calculate the exact value of u and the exact value of v and find out the answer, which is minus 1 by 4. In this question, we are given a function f of x is equal to max of 5x comma 52 minus 2x square, and it is told that x is a positive real number. Now we are required to find out the minimum possible value of f of x. So there are many ways to do it, but in general, whenever we have a functions question where we are asked to find out the minimum or the maximum value of a function which is of this sort, where there are 2 or 3 functions, I would first suggest you to draw the graphs. So then you will get an implicit understanding of what exactly we have and what exactly we have to find out. So if you are looking at 5x, let us first draw the x-axis and the y-axis. 5x will be something which will pass through origin and it will have a slope which is greater than 1. It will have a slope which is equal to 5. This is basically y is equal to 5x. Now to draw the graph of y is equal to 52 minus 2x square, let us first draw the graph of 2x square. So 2x square will look something like this. 2x square is a parabola which will go through the origin and it will go something like this. This is 2x square. Because we are looking for minus 2x square, it will be the exact opposite. So this will be something like minus 2x square. But because we want 52 minus 2x square, we will just bring the graph up by 52. So it will look something like this. This is y is equal to 52 minus 2x square. Now on this, if you are looking at, if you are imposing y is equal to 5x, it will look something like this. So this is basically the graph. Now if you are looking for the graph y is equal to, or f of x is equal to maximum of 5x comma 52 minus 2x square, we will have to look at both the graphs and see where they intersect. So initially when you are starting from origin, y is equal to 52 minus 2x square will be higher. So the graph will be something like this. At some point there will be an intersection between 52 minus 2x square and 5x. After that the graph will be just the line y is equal to 5x. So this is basically how the graph f of x is equal to max of 5x comma 52 minus 2x square will look like. Now we are required to find out the minimum possible value of f of x. That is basically this point. So let us first calculate the point of intersection of 5x is and 52 minus 2x square. Once we calculate the point of intersection, we will get the value of x at which the minimum occurs, and from there we will calculate the value of f of x. So at the point of intersection, 5x is equal to 52 minus 2x square, and we also know that x is greater than 0. Now this is a simple quadratic equation which you can solve. This will be 2x square minus 2x square plus 5x minus 52 is equal to 0. Now you want to split plus 5x so that it is easily factorizable. Now you have to split it in such a way that the difference between them is 5 and their product is 2 into 52. 2 into 52 is 104, which is basically 13 into 8. You can also observe that the difference between 13 and 8 is 5. So let us factorize this easily. This will be 2x square plus 13x minus 8x. Again notice that 13x minus 8x is 5x and their product is equal to 104 minus 52 is equal to 0. or x into 2x plus 13 minus 4 into 2x plus 13 is equal to 0, or x minus 4 into 2x plus 13 is equal to 0. This would imply that x is either equal to 4 or minus 13 by 2. But x cannot equal minus 13 by 2. We know that x is greater than 0. That is basically the point of intersection in the fourth quadrant. They'll again intersect somewhere in the fourth quadrant or the third quadrant, but we don't need that. Anyway, because we know that x is greater than 0, the value of x has to equal 4. And at x is equal to 4, the value of f of x will be, you can calculate the value of 5x. 5x is equal to 20. Similarly, 52 minus 2x square will also equal 20, because both of them are exactly the same when x is equal to 4. Therefore, the value of f of x when x is equal to 4 is 20, and this is the minimum possible value of f of x. So, the answer in this case is 20. In this question, we are required to find out the smallest integer n for which the cubic equation n cube minus 11n square plus 32n minus 28 is greater than 0. So, whenever you see this kind of a question, the first thing that you should try to do is try to factorize this cubic equation. So, to factorize, we will have to find out at least one factor, because factorizing a quadratic equation is very easy, but factorizing a cubic equation is slightly more tricky. So, we will try to find out at least one factor for this cubic equation. Once we find out one factor, we will convert this into a quadratic equation and then try to answer the question. Now, to find out at least one number, substitute n is equal to 1 in this. Now, if you substitute n is equal to 1, what will this become? This will be 1 cube, that is 1, minus 11 into 1 square, that is 11, plus 32 into 1 is 32, minus 28. This is minus 10 plus 32 is 22. 22 minus 28 is minus 6. As this resultant number is not equal to 0, we can infer that n minus 1 is not a factor of the cubic equation. Now, let us substitute n is equal to 2. Now, if you substitute n is equal to 2, n cube will be 8 minus 11 into n square is 11 into 4, that is 44, plus 32 into n is 32 into 2, that is 64, minus 28. This will be 8 minus 44 is minus 36, minus 36 plus 64 is 28, 28 minus 28 is equal to 0. Now, we have noticed that this becomes 0 whenever n is equal to 2. This would imply that n minus 2 is a factor of this given cubic equation. So, once we know that n minus 2 is a factor, we will try to factorize this in such a way that we can find this as n minus 2 into a quadratic equation. Now, how are we going to transform this cubic equation? We will first write down n cube minus 2n square. Why are we writing it as minus 2n square? Because we want to take n square common here, and this will become n minus 2. So, once you have minus 2n square, you have to subtract another minus 9n square, because the total over here is 11. So, this will be minus 9n square, and if you want to again take n minus 2 common, the next number has to be plus 18n, because what we want to do over here is that we will take minus 9n common. So, this will be again n minus 2. You have taken 18n over here, but the total over here is 32. So, the remaining number is plus 14n minus 28. Over here you will take again n minus 2 common, so it will be 14. So, what we have done is we have factorized the given cubic equation into n minus 2 into a quadratic equation, and the quadratic equation over here is n square minus 9n plus 14. Now, this is the quadratic equation that you have. This can be easily factorized as n minus 2 into n minus 2 into n minus 7. 9 square minus 9n plus 14 is equal to n minus 2 into n minus 7. So, we are required to find out the smallest integer n such that n minus 2 into n minus 2 into n minus 7 is greater than 0, or n minus 2 whole square into n minus 7 is greater than 0. Now, clearly n minus 2 whole square is always greater than 0, irrespective of what the value of n is. It is actually greater than or equal to 0 It will equal 0 when n is equal to 2. For every other integer, n minus 2 is always greater than 0. So we can actually ignore this. The only thing that we should be concerned about is that n minus 7 has to be greater than 0. And the smallest integer n for which n minus 7 is greater than 0 is when n is equal to 8. So the answer in this case is 8. What we have done is we have first found out one factor for the given cubic equation. Once we realize that n minus 2 is a factor, we have tried to simplify this cubic equation into n minus 2 into a quadratic equation. Once we had this quadratic equation, we factorized the quadratic equation. So we found out that this is equal to n minus 2 whole square into n minus 7. Now n minus 2 whole square is always greater than 0, so we'll ignore it for this question. We just have to find out the smallest integer n for which n minus 7 is greater than 0, and that will happen when n is equal to 8. So the answer is 8. In this question, we are given two quadratic equations in x. We are told that a and b are integers such that 2x square minus ax plus 2 is always greater than 0, and x square minus bx plus 8 is also always greater than or equal to 0 for all real numbers x. Then we are required to find out the largest possible value of 2a minus 6b. Just to recollect, if any quadratic equation ax square plus bx plus c is always greater than 0 for all values of x, this is possible only if the discriminant is less than 0. Now the discriminant for any quadratic equation is b square minus 4ac. Now if this equation ax square plus bx plus c is always greater than 0 for all values of x, it would imply that b square minus 4ac is less than 0. Similarly, if ax square plus bx plus c is always greater than or equal to 0, it would imply that the discriminant is also always less than or equal to 0, or b square minus 4ac is less than or equal to 0. So we'll use this simple concept to find out the range for a, and we'll find out the range for b, and once we find both of them out, we'll find out the maximum possible value of 2a minus 6b. So because 2x square minus ax plus 2 is always greater than 0, this would imply that the discriminant is always less than 0. This is a strict inequality. Now discriminant is b square minus 4ac, that is the coefficient of x whole square, which is a square, minus 4 times the coefficient of x square, that is 2, into the constant term, that is 2, is strictly less than 0, or a square is strictly less than 16, or a lies between minus 4 and plus 4. Notice that because there is a strict greater than here, a will strictly lie between minus 4 and 4. A cannot be minus 4 or 4. And because we know that a is an integer, this would imply that a belongs to the set minus 3, minus 2, minus 1, 0, 1, 2 and 3. We'll do the same thing even for b. Here we are told that x square minus bx plus 8 is greater than or equal to 0. So the discriminant is less than or equal to 0. Now again the discriminant is b square minus 4ac. So b is basically the coefficient of x. So this will be b square minus 4 into a is the coefficient of x square. In this case it is 1, into c is the constant term. In this case the constant term is 8. This is less than or equal to 0, or b square is less than or equal to 32. This would imply that b lies between minus square root of 32 to positive square root of 32. Again, as b is an integer, this would imply that b belongs to the set minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 and 5. So a can take these 7 values and b can take these 11 values. Now we are required to find out the maximum value of 2a minus 6b. Therefore, to maximize 2a minus 6b, a has to be maximum and b has to be minimum, because the coefficient of b over here is negative. The maximum value of a is 3 and the minimum value of b is minus 5. So the maximum value of 2a minus 6b will be 2 into 3 minus 6 into minus 5. 2 into 3 is 6, minus of 6 into minus 5 is minus 30. So this will be 6 plus 30, which is equal to 36. So the answer in this case is 36. In this question, we are told that a is a real number and we are required to find out the values that a can take for the equation x square minus 4x minus log of a to the base 2 to have real and distinct roots. So let us have a quick recap of quadratic equations. The quadratic equation ax square plus bx plus c is equal to 0 will have real and distinct roots if and only if the discriminant d is greater than 0. What is the value of the discriminant? This is equal to b square, that is the coefficient of x, minus 4ac should be greater than 0. It should be strictly greater than 0. This is when both the roots, that is if you say all they are alpha and beta, they are real and distinct. Now if b square minus 4ac is equal to 0, then both the roots are real and equal, that is alpha is equal to beta. If b square minus 4ac is less than 0, then both the roots alpha and beta will be imaginary. In this case, we are asked to find out the value of a for which the quadratic equation has real and distinct roots. So we know that b square minus 4ac is greater than 0. Now for the quadratic equation x square minus 4x minus log of a to the base 2 is equal to 0, a is equal to 1, a is the coefficient of x square, b is equal to minus 4, b is the coefficient of x, and c is the constant term. This will equal minus log of a to the base 2. Now we can use the same formula, that is b square minus 4ac is greater than 0. So b square is 16 minus 4ac is 4 into a is 1 into minus log of a to the base 2 is strictly greater than 0. That is 16 plus 4 log a to the base 2 is greater than 0, or 4 plus log a to the base 2 is greater than 0, or log of a to the base 2 is greater than minus 4. Now we know that the base of a logarithm is greater than 1. So we can simply take it to the other side and say that a is greater than 2 to the power minus 4, which is equal to 1 by 16. So whenever a is greater than 1 by 16, the quadratic equation x square minus 4x minus log a to the base 2 will have real and distinct roots. In this question, we are given that a quadratic equation x square plus bx plus c has two roots which are 4a and 3a, where a is an integer. We are required to find out which of the following is a possible value of b square plus c. So let us assume that because we are told that a quadratic equation has these two numbers as roots, that is 4a and 3a, this quadratic equation is of the form x minus 4a into x minus 3a is equal to 0. If you simplify this, you will get that x square minus 7ax plus 12a square is equal to 0 for some integer a. But this would imply that b is equal to minus 7a for some integer a and c is equal to 12a square for some integer a. So the value of b square plus c will become b square is 7a square minus 7a square, which is 49a square, and c is 12a square. So b square plus c is of the form 61a square. So now we will have to look at all the options, see which of the options are multiples of 61, then divide that options by 61 and we should get a perfect square. Then that is a valid option. In this case, for example, 3721 is equal to 61 square. So if 3721 is equal to 61 square, it would mean that because this also equals 61a square, 61a square is equal to 3721, or a square is equal to 61. But a is an integer, so a square cannot be 61 because root of 61 is not an integer. So this is not a valid option. Now let us see if b square plus c can be 427. If b square plus c is equal to 427, it would imply that 61a square is equal to 427. Remember that 427 is equal to 61 into 7. So this would imply that a square is equal to 7. Again, this is not possible because 7 is not a perfect square. So this is also cancelled. Now let us look at option B, which is 361. If b square plus c is equal to 361, it would imply that 61a square is equal to 361, but 361 is not a multiple of 61. This is equal to actually 19 square, and so a will not be an integer even in this case. Now let us look at the final option, which is 549. If 61a square is equal to 549, it would imply that a square is equal to 9, so a can be plus or minus 3. This is a valid integer. So the correct answer is option D, which is 549. In this question, we are given a logarithm in terms of x to the base e, and we are required to find out the interval within which x can vary for this logarithm to be a real number. So if you look at it carefully, we want square root of log e to the base 4x minus x square by 3 to be a real number. For this to be a real number, the term which is of which we are taking this root of should be greater than 0. That is, log of 4x minus x square by 3 to the base e has to be greater than or equal to 0. Only then will the square root be defined. Now if you are looking at this logarithm, the base of this logarithm is e, which is approximately equal to 2.7. That is, it is greater than 1. So the logarithm of a number is greater than or equal to 0 only if that number is greater than or equal to 1. That is, logarithm of a to the base b will be greater than or equal to 0 if a is greater than or equal to 1. This is true if b is greater than 1. So in this case, as e is greater than 1, for this entire logarithm to be greater than or equal to 0, 4x minus x square by 3 has to be greater than or equal to 1. When this term equals 1, the logarithm will become 0. So let us just simplify this and then find out the interval within which x has to be present. So as 3 is a positive number, we can multiply both sides with 3. So 4x minus x square has to be greater than or equal to 3, or x square minus 4x plus 3 has to be less than or equal to 0. You can factorize this as x minus 1 into x minus 3 has to be less than or equal to 0. This would imply that x must belong between 1 and 3. Both of them are included because it is less than or equal to 0. That is, 1 has to be less than or equal to x has to be less than or equal to 3. Or if you look at the options, it is option A.
We at Krakow provide all the previous year CAT papers along with many other MBA examinations such as IIFT, ZAT, SNAP, MAT, CMAT, TIS and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.
In this question, we are given two equations in x and y. In both of them, we are given 5 to the power x and 3 to the power y. We are required to find out the value of x plus y. So to solve this, we'll first find out the value of 5 to the power x and 3 to the power y. Then calculate the value of x and y from it, and then calculate what is the value of x plus y. So if you look at both of the equations that are given to us, they are relating to 5 to the power x and 3 to the power y. So what we'll do is, we'll consider 5 to the power x to be equal to a and 3 to the power y to be equal to b. So we'll first find out the value of a and b. From that, we'll find out the value of x and y, and then calculate x plus y. So the first equation transforms to a minus b is equal to 13438. Now as 5 to the power x is equal to a minus 1, 5 to the power x minus 1, which is equal to 5 to the power x by 5, will equal a by 5. Similarly, as 3 to the power y is equal to b, 3 to the power y plus 1 is equal to 3 into 3 to the power y, which will equal 3b. So the second equation will be a by 5 plus 3b is equal to 9686. So we have to just solve these two equations. These are linear equations in two variables. Calculate the value of a and b. We can do that simply by multiplying the second equation with 5. So 2 into 5 will become a plus 15b is equal to 9686 into 5. You can use your calculator to calculate it. This will equal 48430. And from the first equation, we know that a minus b is equal to 13438. So if you just subtract the second equation from the first equation, you can cancel a out. So this will be 16b is equal to 29943. Now, so b will equal 34992 by 16. Again, you can use your calculator. This will equal 2187. Now, we can easily use the first equation and calculate the value of a, which will equal 2187 plus 13438. This, if you simplify, this will be 5. 8 plus 3 is 2. 1 plus 4 is 6. 5. 15625. So, this is equal to 3 to the power y, or y is equal to 7, because 3 to the power 7 is 2187. This is equal to 5 to the power x, or x is equal to 625 into 5 into 5. So, this will be 6. Therefore, x plus y will equal 6 plus 7, which is equal to 13. So, the answer in this case is 13.
In this question, it is given that in 2010, a library had 11,500 books and there were two categories, fiction and non-fiction. So, in 2010, there were a total of 11,500 books and they were in fiction and non-fiction. In 2015, the library contained a total of 12,760 books. In 2015, the library contained 12,760 books. Now, during this period, there was a 10% increase in the fiction category. So, the fiction, which was initially F, has become 1.1 F, while there was a 12% increase in the non-fiction category, plus 1.12 non-fiction, because non-fiction has increased by 12%. How many fiction books were there in the library in 2015? So, we are required to find out what is the value of 1.1 into F. This is the number of fiction books in 2015. So, this is a simple case of two linear equations. We have two variables f and nf. We have to solve, find the value of both of them and then calculate the value of 1.1 into f. So, if you look at both of the equations, there are multiple ways in which you can solve them. What I find easier is to multiply the first equation by 1.1. Then we can cancel off 1.1f, find out the value of nf and then come and calculate the value of f. So, if you multiply the first equation with 1.1, the right hand side will be 1.1f plus 1.1 into nf. This is equal to 11,500 into 1.1. You can use your calculator to find out. This will equal 12650. You will be given a calculator in the exam, so this is quite easy to find out. Now just subtract the second equation from the first equation. Now 1.1f will get cancelled. On the right hand side, it will be 1.12 nf minus 1.1f, which is equal to 0.02 nf. On the left hand side, this will be a simple case of subtraction. This will be 110. Now, so you can easily calculate the value of nf. This is equal to 110 divided by 0.02. Again, you can either use a calculator or you can find out that this is actually equal to 110 into 50. This is equal to 5,500. So, using the first equation, you can then calculate the value of f. This is equal to 11,500 minus 5,500, or this is equal to 6,000. Now, the answer is not 6,000 because you shouldn't make that silly mistake. What we are required to find out is the value of 1.1 into f. So, the value of 1.1 into 6,000 is equal to 6,600. So, the answer in this case is 6,600, which is the number of fiction books in 2015.
In this question, it is given that there are four real numbers a, b, x and y such that a square plus b square is equal to 25, x square plus y square is equal to 169, and you are given that ax plus by is equal to 65 and ay minus bx is equal to k, and you are required to find out the value of k. You are either required to find out the value of k or the interval to which k belongs if you are looking at the options. So, first thing that we should notice is the two equations that are given on the left are in squares, and the two equations given in the right are very similar to each other, but they have interchanging coefficients of x. So, the first thing you will do is, and you should also notice that there is plus here and minus here in the second equation. So, let us do one thing. Let us square the first equation, let us square the second equation and add them up. So, basically k square plus 65 square is equal to this square plus this square, which is equal to a square x square plus b square y square plus 2ax by. This is 65 square plus a square y square plus b square x square minus 2ax by. Now if you add both of them, you can cancel out the ax by term, and it will be a square x square plus b square y square plus a square y square plus b square x square. Now we should immediately recognize that this is actually the first equation here into the second equation. So this is actually equal to 25 into 169. So k square plus 65 square is equal to 25 into 169. Now, so k square is equal to 25 into 169 is actually equal to 65 square minus 65 square, which is equal to 0. Why is 25 into 169 equal to 65 square? Because 25 is equal to 5 square and 169 is equal to 13 square. So if you multiply both of them, it will be 5 into 13 whole square, which is equal to 65 square. You can either calculate both of them individually and subtract them. You will get the same answer, which is that k square is equal to 0 or k is equal to 0. So the correct answer is option D, which is equal to 0. In this question, it is given that f is a function such that f of m into m is equal to f of m into f of n for every positive integer m and m. It is also given that f of 1, f of 2 and f of 3, all of them are positive integers. We are also told that f of 1 is less than f of 2, and we are given that f of 24 is equal to 54. We are required to find out the value of f of 18. What is the value of f of 18? So in this question, if you look at it, there are a few clues which are quite important. The clue that f of 1, 2 and 3 are positive integers is very important, because we can then simplify 24 as powers of 2 and 3. Secondly, we are also given the basic equation of f of m into n is equal to f of m into f of n. So using this, we will first try to find out the value of f of 2 and f of 3, and then we will try to find out the value of f of 18. That is our strategy. So for example, f of 2 is equal to f of 2 into 1. Now we are told that f of m into n is equal to f of 2 into f of 1. So f of 2 is equal to f of 2 into f of 1. As all three of them, that is f of 1, f of 2 and f of 3 are positive integers, they can't be equal to 0. So we can actually cancel f of 2 on both sides, and we can conclude that f of 1 is equal to 1. This is the first equation. This would also imply that f of 2 is greater than 1, because f of 2 is greater than f of 1. So f of 2 is a positive integer which is greater than 1. So it will be something like 2 or 3 or something on these lines. Next, we have the clue that f of 24 is equal to 54. Now let us try to simplify f of 24, because 24 is equal to 8 into 3. Now 8 is a power of 2, that is, it is 2 cube into 3. So f of 24 can be definitely expressed as f of in terms of f of 2 and f of 3, and then using that we will try to find out what is the value of f of 2 and what is the value of f of 3. So f of 24 is equal to f of 2 cube into 3. But again, from the equation of f of mn, we know that this is equal to f of 2 cube into f of 3. Now f of 2 cube is equal to f of 2 into 2 into 2. So again, from the given equation, this can be simplified as f of 2 into f of 2 into f of 2. That is, this is equal to f of 2 whole cube. That is, f of 2 cube is equal to f of 2 whole cube. Therefore, f of 24 is equal to f of 2 whole cube into f of 3. This we are told is equal to 54. We are also told that f of 2 and f of 3 are positive integers. We are also told that f of 2 is a natural number which is greater than 1. Now the only way in which this can be expressed, that is 54 can be expressed, is if this is equal to 3 cube into 2. Remember that 54 is equal to 2 into 27. Now the only way in which this will work, in which we can express this as a product of a cube which is greater than 1 and another natural number, is if we express 54 as 3 cube into 2. This would imply that f of 2 is equal to 3 and f of 3 is equal to 2. We can deduce this based on the prime factorization of 54. Now we need to calculate f of 18. f of 18 is equal to f of 3 square, that is 9, into 2. F of 3 square, this will again be simplified as f of 3 square into f of 2. Similar to what we have found out about f of 2 cube, f of 3 square will be equal to f of 3 whole square into f of 2. F of 3 is 2, so it will be 2 square into f of 2 is 3. So this is equal to 4 into 3, which is equal to 12. So the answer in this case is 12. Remember that using the information that is given, especially the very important information that f of 2 and f of 3 are natural numbers, we were able to find out the exact value of f of 2 and exact value of f of 3. Why did we go into that? Because we could realize that 24, the prime factors of 24 are only 2 and 3. Similarly, the prime factors of 18 are also only 2 and 3. So once we find out the value of f of 2 and the value of f of 3, we can easily calculate the value of f of 18. In this question, we are asked to find out the product of the distinct roots of this equation that is given, which is modulus of x square minus x minus 6 is equal to x plus 2. So what we'll do is, because there is modulus over here, we will first consider both the cases. Case 1 is when the expression inside it is negative, and case 2 is when the expression inside it is positive. So we'll divide it into two cases. This is when x square minus x minus 6 is greater than 0, and this is when x square minus x minus 6 is less than 0. If it is equal to 0, it won't matter because it will lie in both the cases, but the answer will remain the same. So in this case, when x square minus x minus 6 is greater than 0, modulus of x square minus x minus 6 will equal x square minus x minus 6. Now we are told that this modulus is equal to x plus 2. So this will mean that x plus 2 is equal to x square minus x minus 6. So then we can simplify it, and it will become x square minus 2x minus 8 is equal to 0. X square minus 2x minus 8 is equal to x minus 4 into x plus 2 is equal to 0, or x is equal to 4 or minus 2. Now we'll have to check if in both these cases x square minus x minus 6 is greater than 0. I'm putting it as greater than or equal to 0 because it won't matter in case of modulus. So when you put x is equal to 4, it will become x square minus x minus 6 will become 16 minus 4 minus 6, which is equal to 6. This is greater than 0, so this is a valid answer. Similarly, when you put x is equal to minus 2, x square will be 4, minus x will be plus 2, and minus 6 will be minus 6. So this is equal to 0. So this is also a valid solution. So in this case, the two solutions that we have are x is equal to 4 and x is equal to minus 2. Similarly, if you consider the case where x square minus x minus 6 is less than or equal to 0, in this case, modulus of x square minus x minus 6 will equal minus of x square plus x plus 6, because this is negative. So modulus of y when y is negative is equal to minus y. This is true whenever y is less than 0. So in this case, x square minus x minus 6 is minus of x square plus x plus 6, but we know that the value of this modulus is equal to x plus 2. So x plus 2 is equal to minus of x square plus x plus 6. You can cancel x and you can take x square to the other side, and then you will get x square is equal to 4, or x is equal to plus 2 or minus 2. Again, we'll have to check whether in this case x square minus x minus 6 is less than or equal to 0. So if you input that, you are going to get if x is equal to 2, it will be 4 minus 2 minus 6. So this is equal to minus 4. So this is a valid solution. If you input x is equal to minus 2, as we have seen earlier, x square minus x minus 6 will equal 0. So this is also a valid solution. So the number of distinct roots that you have are, the actual distinct roots are 4, minus 2 and 2. These are the only three cases. We have considered minus 2 twice because in both the cases we have put greater than or equal to 0. So when you look at the distinct roots, there are 4, minus 2 and 2, and their product will equal minus 2 into 4, which is equal to minus 16. So the answer that we are looking for in this case is minus 16. So whenever you see a question where there is a modulus, try to see if you can consider two different cases where the value inside the modulus is greater than 0 or the value inside the modulus is less than 0. And then you can solve it, find the distinct roots and then answer the question. In this question, a function f is given such that f of x plus y is equal to f of x into f of y, where x and y are positive integers. It is also given that f of 1 is equal to 2. We are also given a function which an expression which says that f of a plus 1 plus f of a plus 2 dot 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 plus f of a plus n is equal to 16 into 2 to the power n minus 1, and we are required to find out the value of a. So let us first look at the expression that is given and try to figure out the values of f of 2, f of 3 and so on to get a sense of how the function actually behaves. So f of 2 is equal to f of 1 plus 1, which according to the function that was given will be f of 1 into f of 1. We are already told that f of 1 is equal to 2, so this will be 2 square. Similarly, f of 3 will be f of 2 plus 1, which is equal to f of 2 into f of 1. f of 2 is 2 square and f of 1 is 2, so this will be equal to 2 cube. You can easily see that f of n will equal 2 to the power n for any natural number n. So the LH, the left hand side of the given expression, that is f of a plus 1 plus f of a plus 2 plus dot 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 plus f of a plus n will equal 2 to the power a plus 1 plus 2 to the power a plus 2 plus dot 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 plus 2 to the power a plus n. Here you can see that all of them are greater than, are powers of 2 which are greater than a plus 1. So let us take 2 to the power a plus 1 common in the sum. So this will be 1 plus 2 plus dot dot dot. The last term will be a plus n minus a plus 1. So that will be plus 2 to the power n minus 1. Now this sum, that is 1 plus 2 plus dot 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 plus 2 to the power n minus 1 equals 2 to the power n minus 1 into 2 to the power a plus 1. This is a simple sum of a geometric progression where the first term is 1 and the common difference is 2 and the common ratio is 2. So this sum actually equals 2 to the power a plus 1 into 2 to the power n minus 1. But we are told that the right hand side, this equals 16 into 2 to the power n minus 1. This is already given in the question. So you can cancel 2 to the power n minus 1 and 2 to the power n minus 1 and come to the conclusion that a plus 1 is equal to 4. A plus 1 is equal to 4 because 16 is equal to 2 to the power 4. So if you are equating the power of 2 on both sides, a plus 1 will equal 4 and a will equal 3. So the answer in this case is 3. To solve this question, you just need to figure out what is the value of f of n. We have figured out that f of n is equal to 2 to the power n. Then notice that all the terms which are given in the left hand side are part of a geometric progression. Calculate the sum of the geometric progression and cancel out the common terms and find out that a is equal to 3, which is the answer. In this question, a function f of n is described such that whenever n is even, f of n is equal to n into n plus 1, and when n is odd, f of n is equal to n plus 3. Now if m is a positive integer such that 8 into f m plus 1 minus f of m is equal to 2, we need to calculate the value of m. Now because the function is different for even numbers and odd numbers, let us consider two cases. The first case is m is even. The second case is m is odd. Now because we need to calculate f of m plus 1 and f of m, we'll also look at what m plus 1 will be in both the cases. Whenever m is even, m plus 1 is odd, and whenever m is odd, m plus 1 is even. So let us consider the first case. So in this case, f of m is equal to m into m plus 1 because m is even, and f of m plus 1, note that m plus 1 will be odd, so f of m plus 1 will be m plus 1 plus 3, which is equal to m plus 4. Now let us find the value of 8 into f of m plus 1 minus f of m. This should equal 2 according to the given equation. 8 into f of m plus 1 will be 8m plus 32 minus f of m will be m square minus m. This is basically m into m plus 1. This is equal to 2. Now if you solve for this, if you simplify this, this is going to be m square minus 7m minus 30 is equal to 0. This is equal to m minus 10 into m plus 3 is equal to 0, or m is equal to 10 or minus 3. As we are told that m is a positive integer, the only value is m is equal to 10, and 10 is an even integer, so 10 is a valid solution. Now let us look at the second case where m is odd, and in that case m plus 1 will be even. So f of m will equal m plus 3. This is again by definition of the function. And f of m plus 1, note that in this case m plus 1 is even, so we will have to apply this formula, will be m plus 1 into m plus 2. Therefore the given equation, that is 8 into f of m plus 1 minus f of m, which equals 2, can be simplified as 8 into m square plus 3m plus 2 minus m minus 3 is equal to 2. If you simplify this, you are going to get 8m square plus 24m plus 16 minus m minus 3 is equal to 2, or 8m square plus 23m plus this is 13 minus 2 is 11 plus 11 is equal to 0. You can note that you can solve for the quadratic equation, but you will see that the solutions for this, the solutions of the two values of m will not be positive integers. So there are no solutions in this case when m is odd. So the only solution is m is equal to 10, which is the answer. In this question, we are required to find out the number of real roots of the equation 2 into cos x into x plus 1 is equal to 2 to the power x plus 2 to the power minus x. So if you look at the RHS, that is the right hand side carefully, this is 2 to the power x plus 1 by 2 to the power x. And 2 to the power x is always positive for any real number x. So the number 2 to the power x plus 1 by 2 to the power x is always greater than or equal to 2. This is because any number a plus 1 by a, where a is positive, is always greater than or equal to 2, and the equality will occur when a is equal to 1. So in this case, 2 to the power x plus 1 by 2 to the power x will equal to when 2 to the power x is equal to 1 or x is equal to 0. Similarly, if you look at the left hand side, 2 cos x into x plus 1 by 1, this is something along the lines 2 into cos of a. Now cos of a is always less than or equal to 1. So 2 into cos of a will always be less than or equal to 2. So the left hand side is always less than or equal to 2, and the right hand side is always greater than or equal to 2. So they will equate to each other only when both of them equal 2. And right hand side is equal to 2 when x is equal to 0. So let us check if left hand side also equals 2 when x is equal to 0. And if you substitute the value of x in left hand side, you are going to get 2 into cos of 0 into 1, which is 0. 2 into cos of 0 is actually equal to 2. So the only point at which left hand side will equal right hand side is when both of them are equal to 2, and both of them equal 2 only when x is equal to 0. So the number of real roots of the equation is 1, and the only real root is x is equal to 0. In this question, we are given that S is the set of all the points x comma y in the xy plane which satisfy these two inequalities. One of the inequalities is modulus of x plus modulus of y is less than or equal to 2, and the second inequality is that modulus of x is greater than or equal to 1. Now we are required to find out the area in square units which is represented by this region. Let us first get the graph down so that we know exactly what is the area that is being discussed. We'll try to see what is the geometric pattern that this area is, and try to find the area of that geometric pattern, geometric shape. So let us first draw the x-axis and the y-axis. Now to get the first inequality, that is modulus of x plus modulus of y is less than or equal to 2, this contains 4 inequalities. The first inequality is x plus y is less than or equal to 2. The second one is x minus y is less than or equal to 2. The third inequality is minus x plus y is less than or equal to 2. And minus x minus y is less than or equal to 2. In each of the quadrants, the inequality will be morphed into one of these 4 inequalities. So you can easily draw the graphs of x plus y is equal to 2. This line meets the x-axis at 2, 0, and it meets the y-axis at 0, 2. Similarly, each of the other 4 inequalities can be represented by identical lines in different quadrants. So this will be how the graph x plus modulus of x plus modulus of y is less than or equal to 2 looks like. This should be a square even though it doesn't look like it. So let us get the points where these meet the axis. So minus 2, minus 2. Now let us look at how the second inequality, that is modulus of x is greater than or equal to 1, looks like. Now whenever x is greater than 0, that inequality will be x is greater than or equal to 1, which will be something like this. This will be the line x is equal to 1, and everything to the right of it will be x is greater than or equal to 1. So whenever x is greater than 0, this is the area of intersection. Similarly, whenever x is less than 1, you will get another line which will be represented by minus x is greater than or equal to 1, because modulus of x when x is less than 0 is minus x. So this will be x is less than or equal to minus 1, which will be all the points to the left of minus 1, 0. And this point will be 1, 0. As you can see, the total area is the area of these two triangles. This is one triangle and this is the second triangle. Again, both the triangles are identical. They don't look that way, but the shapes are exactly the same. So to find out the total area, let us find out the area of one of the triangles and multiply it by 2 to get the total area. To find out the area of the triangle, let us assume that this triangle is A, B and C. We'll need the base of the triangle, that is the length of AB, and the height of the triangle. The height of the triangle, if you assume that this is D, the height of the triangle, that is DC, is quite easy to find out. It is 2 minus 1, which is equal to 1. The height of the triangle is 1 unit because we know the coordinates of C, this is 2, 0, and we know the units of D, which is 1, 0. So the height of the triangle is 1 unit. To find out the base, that is the length of AB, we'll have to find out the points of intersection of the lines x is equal to 1, which is one of the inequalities, along and the two line segments. One of the line segment is x plus y is equal to 2. So the point of intersection, that is this point A, will be 1, 1. So the coordinates of the point A are 1, 1. Similarly, if you calculate the coordinates of point B, they will be 1, minus 1. Therefore, the length of AB is equal to 2 units. This is basically 1 minus minus 1, which is equal to 2 units. Therefore, the area of triangle ABC is equal to half into base into height. This is equal to half into the base is 2 units into the height is 1 unit, which is equal to 1 unit. Now this is only the area of triangle ABC. We need to multiply it by 2 to take care of the second triangle, which is identical to it. Therefore, the total area is 2 units. So the answer that we are looking for is 2 units. In this kind of question, if you first get the shape of the graph correct, most of the work is already done. Then you will have to look for symmetry and try to do the calculations without making any mistake. In this case, you should figure out that once I get the base correct and the height correct, finding the area is very straightforward. In this question, we are required to find out the number of solutions to the equation modulus of x into 6x square plus 1 is equal to 5x square. So in this case, as you can see, there is modulus. So let us consider 3 cases. The first case is when x is less than 0. The second case is when x is equal to 0. And the third case is when x is greater than 0. In each of these cases, we will find out the number of solutions and we will sum them up to get the total number of solutions for the given equation. The easiest one is when x is equal to 0. Just substitute the value of 0 and you can see that the equation is satisfied because both the sides will equal 0. So one of the solutions is x is equal to 0. Now let us try to look at the cases where x is less than 0. When x is less than 0, modulus of x will equal minus x. Therefore the left hand side will equal minus x into 6x square plus 1 is equal to 5x square. Here x is strictly less than 0, so you can cancel x on both sides, and so this becomes 6x square plus 5x plus 1 is equal to 0. You can simplify this, you can factorize this equation as 6x square plus 3x plus 2x plus 1 is equal to 0, or 3x plus 1 into 2x plus 1 is equal to 0, or x is equal to minus 1 by 2 or minus 1 by 3. Notice that in both the cases x is less than 0 in both the solutions that we got in this case. So the number of solutions is increased by 2. So we already had 0, now we can add minus 1 by 2 and minus 1 by 3. Now let us consider the final case where x is strictly greater than 0, that is this case. In this case, modulus of x is equal to x. So the left hand side of the given equation will be x into 6x square plus 1 is equal to 5x square. As x is strictly greater than 0, we can cancel x on both sides. So this will be 6x square minus 5x plus 1 is equal to 0. This is similar to the earlier case, so we can simply factorize it. So this will be 3x minus 1 into 2x minus 1 is equal to 0, or x is equal to 1 by 3 or 1 by 2. Notice that even in this case, both the solutions that we got are greater than 0. So both these two are also valid solutions of the original equation. So if you add them also up, the total number of valid solutions for the given equation is 5. So the answer that we are looking for is 5.
Google search Krakow CAT formulas PDF. Click on the first link. You will get a list of topics for CAT. Click on one of the topics. Download the PDF to get a list of formulas for the topic.
In this question, it is mentioned that a gentleman decided to treat a few children in the following manner. He has a few chocolates. Let us assume that he has 2x chocolates. Then he gives half of the stock of the toffees plus 1 extra chocolate to the first child. So the number of chocolates that the first child received will be equal to x plus 1, because we assumed that the total number of toffees is equal to 2x. And what are the remaining number of chocolates? The remaining number of chocolates after giving some chocolates to the first person is x minus 1. One of the things that we should notice is that the number of chocolates received by a person and the number of chocolates that are left after the toffees were given, the difference between these two is always equal to 2. Now the second child receives half of the remaining chocolates, that is, he receives half of x minus 1. Just for ease, let us assume that x minus 1 is equal to 2x1. Therefore, the number of chocolates that the second child receives is x1 plus 1, and the number of toffees that are remaining is equal to x1 minus 1. Again, the difference between the two is equal to 2. The third person also receives in the same way. Let us continue the same pattern. For ease, let us assume that x1 minus 1 is equal to 2x2. So the number of toffees that the third child receives will be x2 plus 1, and the number of toffees that are left after giving toffees to the third child is x2 minus 1. The difference again is equal to 2. Let us assume that x2 minus 1 is equal to 2x3. Now after giving toffees to the fourth child, that is x3 plus 1, the number of toffees that are remaining is x3 minus 1. Let us assume that this is equal to 2x4. And finally, after giving toffees to the fifth child, there were no toffees left. That is, the fifth child received x4 plus 1 chocolates, and the number of toffees that would have remained is equal to x4 minus 1. But we are told that this is equal to 0. It is mentioned that his entire stock totally exhausts after he gives toffees to the fifth child. So x4 is equal to 0. So the number of toffees that the fifth child has received, this will be equal to 2. So how many chocolates were remaining after giving chocolates to the fourth child? That will be 2 plus 0, which is equal to 2. Therefore, the number of toffees that the fourth child has received will be 2 plus 2, which is equal to 4. Therefore, the number of toffees that are remaining after giving toffees to the third child will be 4 plus 2, which is equal to 6. Therefore, the number of toffees that the third child has received will be equal to 8. After giving the second child, the number of toffees that are left will be 8 plus 6, which is equal to 14. This would imply that the number of toffees that were given to the second child would be 16. And the number of toffees that are left after giving toffees to the first child will be 16 plus 14, which is equal to 30. And the number of toffees that were given to the first child will be equal to 32. Therefore, the number of toffees at the start will be 32 plus 30, which is equal to 62. So, the correct answer is 62. In this question, we are required to find out the number of real valued solutions for the equation 2 to the power x plus 2 to the power minus x is equal to 2 minus x minus 2 whole square. So, if you look at the equation that is given and if you look at the left hand side of the equation, this is equal to 2 to the power x plus 2 to the power minus x, or this is equal to 2 to the power x plus 1 by 2 to the power x. For every value of x which is a real number, 2 to the power x is always greater than 0. So, this term is always greater than 0. So, if you are looking at the term 2 to the power x plus 1 by 2 to the power x, this is always greater than or equal to 2. And the equality occurs, that is 2 to the power x plus 1 by 2 to the power x will be equal to 2 if and only if 2 to the power x is equal to 1 or if the value of x is equal to 0. Because for any positive number, the value of a plus 1 by a is always greater than or equal to 2 by using the arithmetic mean, which is greater than or equal to geometric mean theorem. And the equality will occur if and only if a is equal to 1. So, in this particular case, the left hand side is always greater than or equal to 2 and the equality will occur if x is equal to 0. Now, if you are looking at the right hand side, which is equal to 2 minus x minus 2 whole square, you know that x minus 2 whole square is always greater than or equal to 0. So, 2 minus x minus 2 whole square is always less than or equal to 2 and the equality will occur when x minus 2 is equal to 0 or when x is equal to 2. So, when x is equal to 2, the right hand side will be equal to 2 and for all other values of x, right hand side is less than 2. Similarly, if you are looking at the left hand side will equal to if x is equal to 0 and for all other values of x, the left hand side is greater than 2. So, as you can see, left hand side and right hand side will never be equal to each other because their minimums which are the same, that is the value 2, but they do not occur at the same point. The left hand side reaches its minimum at x is equal to 0 and the right hand side reaches its maximum at x is equal to 2. So, the number of real valued solutions for the given equation is 0. In this question, we are required to find out the distinct positive integer solutions for the equation x square minus 7x plus 11 to the power x square minus 13x plus 42 is equal to 1. Here we know that x is a distinct positive integer. So, the value of x square minus 7x plus 11 will be an integer. It might be positive or negative, but this will be an integer. Similarly, even the term in the exponent, that is x square minus 13x plus 42 will also be an integer. So, this is of the form a to the power b is equal to 1, where a and b are both integers. So, there are three possible cases for this to happen. The first case is that the number in the exponent is equal to 0, that is b is equal to 0. The second case is that a is equal to 1. This is of the form 1 to the power anything, that will be equal to 1. The third case is that a is equal to minus 1 and b is an even number. This is of the form minus 1 to the power 4 or minus 1 to the power 10. So, let us try to see how many possibilities are there for each of these three cases. In the first case, when the number in the power is equal to 0, that would mean that x square minus 13x plus 42 is equal to 0. This can be factorized as x minus 6 into x minus 7 is equal to 0, or the value of x has to be either 6 or 7. In the second case, where the number in the base is equal to 1, it would imply that x square minus 7x plus 11 is equal to 1, or x square minus 7x plus 10 is equal to 0. This can be factorized as x minus 2 into x minus 5 is equal to 0. So, this would imply that x is equal to either 2 or 5. Finally, in the last case, we want the number in the base to be equal to minus 1 and the number in the exponent to be an even number. So we want first x square minus 7x plus 11 to be equal to minus 1, or this would imply that x square minus 7x plus 12 is equal to 0, or this would be x minus 3 into x minus 4 is equal to 0. So x is equal to either 3 or x is equal to 4. But now we have to check if when x is equal to 3, the number in the numerator, whether it is even or odd. The number in the numerator will be equal to, in the exponent will be equal to x square minus 13x plus 42. When x is equal to 3, this will equal 9 minus 39 plus 42, which will equal 12, which is an even number. So this is a valid solution. Similarly, when x is equal to 4, what is the value of x square minus 13x plus 42? That will be 16 minus 13 into 4 is 52 plus 42. This is equal to 6. This is also an even number, so this is also a valid solution. So the total number of valid solutions will be 2 plus 2 plus 2, which is equal to 6. In this question, we are asked to find out the area of the region which is satisfied by the three inequalities. The first inequality is modulus of x minus y is less than or equal to 1. The second one is that y is greater than or equal to 0, and the third one is that y is less than or equal to 1. So in order to find out the area bounded by the region, let us first draw the graph and try to understand what that region actually is. So let us first draw the y-axis and the x-axis. Now two lines are quite easy to draw. The first one is y is greater than or equal to 0 will be above the y-axis. This is the above the x-axis. So this is the first half, and the second one which says that y is less than or equal to 1 can also be easily drawn. For that, let us first draw the line y is equal to 1. This will be a line which is parallel to the x-axis. So all the area which is between these two lines is bounded by the two lines, two inequalities, y is greater than or equal to 0 and y is less than or equal to 1. The only thing which is slightly more tricky is drawing the graph modulus of x minus y is less than or equal to 1. Or this would imply that modulus of x minus y is less than or equal to 1, or modulus of x is less than or equal to y plus 1. Here there are two cases. The first case is when x is less than 0, and the second case is when x is greater than 0. When x is greater than 0, the inequality becomes equal to x is less than or equal to y plus 1. In order to draw this inequality, let us first draw the line x is equal to y plus 1. X is equal to y plus 1 will be a line which has a slope of 1, which will be only in the positive direction. So it will be something like this. This is the line x is equal to y plus 1. And if you are trying to figure out which of the two sides, that is it above the line or below the line, which is the inequality x is less than or equal to y plus 1, try to see if origin, which lies on one side of the line, satisfies this inequality or not. Origin is 0, 0. In this particular case, x, which is 0, is less than or equal to y plus 1. So this satisfies the inequality. So the given area is this. If you are looking at the second case where x is less than or equal to x is less than 0, then the inequality will become equal to minus x is less than or equal to y plus 1, or x plus y is greater than or equal to minus 1. So again, to draw this, let us first draw the graph which is x plus y is equal to minus 1. That will have a slope of minus 1. It will be exactly the mirror image of the earlier line. It will be something like this. And again, if you are trying to find out which side is it above the line or below the line which satisfies the given inequality, again try to see if origin, which is 0, 0, satisfies this inequality. 0, 0 would imply that x plus y is also equal to 0, which is definitely greater than or equal to minus 1. So origin satisfies this inequality. So the required region is over here. So the area that we are trying to find out is the area of a trapezium. If you are actually trying to name the vertices, let us call this to be equal to A, B, C, D and E. We are required to find out the area of the trapezium B, C, D, E. If you are trying to find out the area of the trapezium, the easiest way to do it is calculating the area of triangle AED, and from it subtract the area of the triangle ABC. So let us first put down the coordinates. E will be equal to minus 2, 1. D will be equal to 2, 1. C will be equal to 1 comma 0 and b will be equal to minus 1 comma 0 and a is equal to 0 comma minus 1, and let us assume that this point is equal to f. The area of triangle AED is equal to half into base into height, that is equal to half into DE into FA, and area of ABC will be again equal to half into base into height, so this is equal to half into BC into, if you assume that this point origin is O, AO. The length of each of this is known to us. DE is equal to 2 plus 2, that is equal to 4, so this is half into 4 into FA will be equal to 1 plus 1, so that is equal to 2, minus BC is equal to 2 and AO is equal to 1. So this is equal to 4 minus 1, which is equal to 3 units. So the required area which is bounded by these three inequalities is equal to 3 square units. In this question we are told that there are 100 students, of which x1 have their birthdays in January, x2 have it in February and so on, and x0 is the maximum of x1 plus x2 plus dot 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 till x12, then the smallest possible value of x0 is what we are supposed to calculate. So we have 12 numbers, x1 plus x2 plus dot 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 plus x12, this is equal to 100, and out of these 12 numbers we are supposed to distribute them in such a way that the maximum out of these 12 will be the lowest. So how do we do that? Suppose we do it in the extreme manner, that is if we give all 100 in one month, say December, and in all the remaining months we give 0. Just to understand how this works, then the value of x0 will be the maximum of x1 to x12, which will itself equal 100. But x0 is what we are trying to minimize. We want to decrease this to as low as possible. So suppose we make two numbers, that is x12 and x11 to be equal to 50, and we keep all the remaining to be equal to 0. Then what is the value of x0? In that particular case, x0 is the maximum of all of these 12 numbers, which will equal 50. So this has decreased, but we want to decrease this further. So as you can see, if we distribute this 100 as evenly as possible amongst these 12 numbers, then the value of x0 will be as low as it can. So if you are trying to distribute 100 across 12 numbers in an even manner, each of the numbers should equal 100 divided by 12, which is equal to 8.33. But 8.33 is not a natural number, so we can't, or an integer, so we can't distribute it this way. So what we will do is, in all the 12 numbers we are going to give 8, so there will be 12 8s, the total will equal 96. We still have to distribute 4, so 4 of these 8s we will convert them into 9s. So we will have 8 8s, which will become equal to 64, and we will have 4 9s, which will equal 36. The total will equal 100. In this particular case, the maximum out of these 12 numbers, that is 8 8s and 4 9s, x0 will equal 9, which is the smallest possible value of x0. So the correct answer is 9. In this question, we are asked to find out the number of distinct real roots for the equation x plus 1 by x whole square minus 3 times x plus 1 by x plus 2 is equal to 0. So let us assume that the value of x plus 1 by x is equal to a. We are told that x and 1 by x, both of them are real numbers. So the value of a will be either greater than or equal to 2 if x is positive, or a will be less than or equal to 2 if x is negative. Because if say x is positive, x plus 1 by x, both of them will be positive. So divided by 2 will be greater than or equal to square root of x into 1 by x. This is by the arithmetic mean is greater than or equal to geometric mean theorem. So the right hand side will become equal to 1. So x plus 1 by x will be greater than or equal to 2. This is valid if x is greater than 0. Similarly, if x is less than 0, we can prove that a will be less than or equal to minus 2. So if x is positive, a is greater than or equal to 2. If x is negative, a is less than or equal to minus 2. In this particular case, the given equation will be transformed to a square minus 3a plus 2 is equal to 0. This is a quadratic equation, so we can simplify this as a minus 2 into a minus 1 is equal to 0, or the value of a is either equal to 1 or the value of a is equal to 2. X plus 1 by x, as we have discussed earlier, cannot equal 1. X plus 1 by x will definitely be greater than or equal to 2, so this is not valid. So we can ensure that x plus 1 by x is equal to 2, or you can simplify this as x square minus 2x plus 1 is equal to 0. If you just multiply the left hand side and right hand side with x, you are going to get x square plus 1 is equal to 2x, or x square minus 2x plus 1 is equal to 0. This would imply that x minus 1 whole square is equal to 0, or the value of x is equal to 1. So the only real root for the given equation is x is equal to 1. So it has one real root. In this question, it is given that f of x is a function such that f of 5 plus x is equal to f of 5 minus x for every real value of x. We are also told that f of x is equal to 0 has 4 distinct real roots, and we are asked to find out the sum of these roots. So just to understand this function, let us assume that 5 plus x is equal to y. Then let us try to calculate what is the value of 5 minus x. So 5 plus x is equal to y, or x is equal to y minus 5. Therefore, the value of 5 minus x will be equal to 5 minus of y minus 5, which is equal to 10 minus y. So essentially what is given to us is that for every value of y, f of y is equal to f of 10 minus y. Now we are told that f of x is equal to 0 has 4 distinct real roots. So if you assume that one of the roots is f of a, this is equal to 0, then f of 10 minus a will also be equal to 0. If you assume that another root is b, such that f of b is equal to 0, then the other root will have to be f of 10 minus b. This will also equal 0. So the 4 roots will be a 10 minus a for some value of a, and b and 10 minus b for some value of b. So the sum of all of these 4 roots will be a plus 10 minus a, which is equal to 10, and b plus 10 minus b, which is also equal to 10. So the sum of the 4 roots will be 10 plus 10, which is equal to 20. In this question, we are told that a, b and c are 3 positive integers such that the sum of a and the mean of b and c is 5. That is, a plus b plus c divided by 2 is equal to 5. We are also told that the sum of b and the mean of a and c is 7. That is, the value of b plus a plus c divided by 2 is equal to 7. So let us multiply both the equations by 2 so that we can remove the denominator. So this would imply that 2a plus b plus c is equal to 10, and the value of 2b plus a plus c is equal to 14. This is the first equation and this is the second equation. Let us subtract 2 minus 1. So the equation 2 minus 1 would imply that b minus a is equal to 4. We are told that a, b and c, all of them are positive integers. So the value of b can be equal to 5, in which case a will equal 1, or the value of b can be equal to 6, in which case the value of a will be equal to 2. Note that the value of b cannot be equal to 7 or more, because we have b plus a plus c by 2 to equal 7. The mean of a and c, because both of them are positive integers, this mean will be greater than or equal to 1. Therefore, the value of b has to be less than or equal to 6. So the only two cases that we need to consider are b is equal to 5 and a is equal to 1, or b is equal to 6 and a is equal to 2. If b is equal to 6 and a is equal to 2, from the second equation, what will the value of c be? The value of c will be equal to 0, because 2b will be equal to 12 and a is equal to 2. So 12 plus 2 is 14. So the value of c will equal 0. So this is not possible, because we want all the three of them to be positive integers. If b is equal to 5 and a is equal to 1, what is the value of c? In that case, 2b is equal to 10 and the value of a is equal to 1. So the value of c will be 14 minus 11, which is equal to 3. In this particular case, all the three numbers a, b and c are positive integers. So this is a valid solution, and we are required to calculate the sum of a plus b. So the sum of a plus b will be 5 plus 1, which is equal to 6. In this question, we are told that x square plus mx plus 2n is equal to 0, and the other quadratic equation x square plus 2nx plus m is equal to 0. Both of them have real roots, and we are also told that m and n are positive integers. A quadratic equation which is of the form ax square plus bx plus c is equal to 0. This will have real roots if and only if the discriminant is greater than or equal to 0. The discriminant is equal to b square minus 4ac. This has to be greater than or equal to 0 for the given quadratic equation to have real roots. So the first quadratic equation will have real roots if m square minus 4 times 1 into 2n, that is 8n, is greater than or equal to 0, or if m square is greater than or equal to 8n. This is the first inequality. The second quadratic equation will have real roots if again its own discriminant is greater than or equal to 0. That would imply that 4n square minus 4 times the coefficient of x square is 1 and the constant term is m. So 4n square minus 4m is greater than or equal to 0, or n square is greater than or equal to m. This is the second inequality. We are told that m and n, both of them are positive integers, and we are required to calculate the smallest possible value of m plus n. Here we are told that m is less than or equal to n square. Therefore, m square is less than or equal to n to the power 4, but m square itself is greater than or equal to 8n. So this is greater than or equal to 8n. What this would imply is that n to the power 4 is greater than or equal to 8n, or n cube is greater than or equal to 8, or n itself is greater than or equal to 2. Similarly, because m square is greater than or equal to 8n, m square will be greater than or equal to 8 times 2, which is equal to 16, or m itself will be greater than or equal to 4. So what we know for sure is that m is greater than or equal to 4 and n is greater than or equal to 2. As we are trying to find out the minimum possible value of m plus n, we'll first check for the least possible values of m and least possible values of n, and we'll see if both these inequalities hold true. If both of them hold true, then we know that the minimum possible value of m plus n can be easily calculated. So the minimum possible value of m is 4 and the minimum possible value of n is 2. We'll check for the first inequality. What is the value of m square? That will be 16 is greater than or equal to 8 into 2, that is 16. Because the inequality is also there, the first inequality is true. If you are looking at the second inequality, n square is greater than or equal to n. What is the value of n square? It will be 4 is greater than or equal to m is 4. Again we have the equality, so even the second inequality is true. So both the inequalities are true when m is equal to 4 and n is equal to 2. So the minimum possible value of m plus n will be equal to 6. In this question we are told that Dick is thrice as old as Tom and Harry is twice as old as Dick. So we have three guys, we have Dick, have Tom, and we have Harry. Dick is thrice as old as Tom, so let us assume that Tom is x years old, so Dick will be 3x years old, and Harry is twice as old as Dick, so the age of Harry will be 6x. Now Dick's age is 1 year less than the average of all the three. What is the average age of all the three? It will be 3x plus 6x divided by 3, so that is equal to 10x by 3. This is the average. If you subtract Dick's age from this difference is equal to 1, or 10x by 3 minus 3x, which is equal to x by 3 is equal to 1, or the value of x is equal to 3. We are asked to find out Harry's age. Harry's age is 6x, so the value of 6 into 3, which is equal to 18, will be Harry's age. So the correct answer will be 18.
Google search Krakow free cat mock. Click on the first link. You can attempt a free mock test which was attempted by 30,000 cat aspirants in the actual exam format. After completing the test, you get detailed solutions, analysis and percentile along with your scorecard to gauge your All India performance. Click on the solution to get video solutions from our expert faculty.
In this question we are told that k is a constant and we are given two equations. The first equation is kx plus y is equal to 3 and the second equation is 4x plus ky is equal to 4, and we are required to find out for which of these conditions does the set of these two equations have a unique solution. If you are given two equations which are of the form ax plus by is equal to p and cx plus dy is equal to q, this set can have three cases. The first case is that this pair of equations has a unique solution. The second case is that this pair of equations has infinite solutions. And the third case is that this pair of equations has no solution. This pair of equations will have a unique solution if a by c is not equal to b by d. that is the coefficients of x and y should not be in proportion in both the equations. In that particular case, which is required for this question, this pair of equations will have a unique solution. But if a by c is equal to b by d, then there are two cases possible. If a by c is equal to b by d, which is also equal to p by q, that is the ratio of the constants, then this pair of equations will have infinite solutions. That is, for any value of x and y, this will be satisfied. But this pair of equations will have no solution if a by c is equal to b by d, like in the second case, but this ratio is not equal to p by q. In this particular case, the set of equations will have no solution. What we are required over here is to figure out the case where this pair of equations has a unique solution. So we want k by 4 to be not equal to the coefficient of y in the first equation is 1 divided by k, or we want k square to be not equal to 4. In that particular case, this pair of equations will have a unique solution. So k should not equal plus or minus 2, or modulus of k should not equal 2. So the correct answer is option A. In this question, we are asked to find out the area in square units, which is enclosed by the lines x is equal to 2, y is equal to modulus of x minus 2 plus 4, the x axis and the y axis. So before we actually find out the answer, let us first draw all the lines and try to identify what is the area that is being discussed. So first let us draw the y axis, then we will draw the x axis. We can also draw the line x is equal to 2, that will be a line which is parallel to the y axis, so it will be somewhere over here. And we also have to draw the line y is equal to modulus of x minus 2 plus 4. So this is y is equal to modulus of x minus 2 plus 4. Now as we are only concerned with the area which is between x is equal to 0 and x is equal to 2, that is y axis and x is equal to 2, we can only consider the case in this modulus where x is less than 2. Because when x is greater than 2, the area will be to the right of the given line, x is equal to 2, and is irrelevant to this question. So in this particular case, let us assume and let us try to draw the graph of the line y is equal to modulus of x minus 2 plus 4, where x is less than 2. In that particular case, this will transform to y is equal to 2 minus x plus 4, or the value of y plus x will equal 6. So what does the line x plus y is equal to 6 look like? When x is equal to 0, which is the equation of the y axis, the value of y will be 6. So it will be somewhere over here. The point over here will be 0, 6. And when x is equal to 2, the value of y will be equal to 4. So it will be somewhere over here. So this is equal to 2, 4. So if you join these 2 points, you are going to get the line x plus y is equal to 6. Now the area that is being discussed is this trapezium, and we are asked to find out this area. To find out the area of a trapezium, we need to know the lengths of the parallel sides and the distance between them. The distance between them is equal to 2 units, because one line is x is equal to 0 and the other line is x is equal to 2. The length of one parallel side is 6 units. This is from 0, 0 to 0, 6. And the length of the second parallel side is 4 units. This is from 2, 0 to 2, 4. So the overall area will be half into sum of the lengths of the parallel sides, which is 6 plus 4, into the distance between them, which is equal to 2. You can cancel 2 and 2, so this will equal 10 square units. So the area that is bounded by the given lines is 10 square units. In this question, we are told that f of x plus y is equal to f of x into f of y, and we are told that the value of f of 5 is equal to 4. And we are required to calculate the value of f of 10 minus f of minus 10. We are given the value of f of 5. So the value of f of 10, which is equal to f of 5 plus 5, can be calculated. This will be equal to f of 5 into f of 5, or this is equal to 4 into 4, which is equal to 16. So as f of 5 is equal to 4, the value of f of 10 is equal to 16. Now as f of 10 is equal to 16, we will try to calculate the value of f of minus 5, and then we will calculate the value of f of minus 10. What is the value of f of minus 5? Let us assume that the value of f of minus 5 is equal to k. Therefore, the value of 5 can be written as the value of minus 5 plus 10, which will then equal f of minus 5 into f of 10. The value of f of 5 we know is already given to be equal to 4. If you assume that the value of f of minus 5 is equal to k, this will equal k into f of 10, which we have just calculated, will equal 16. Or the value of k is equal to 4 by 16, which is equal to 1 by 4. This is the value of f of minus 5. So if f of minus 5 is equal to 1 by 4, what is the value of f of minus 10? F of minus 10 will equal f of minus 5 plus minus 5, or this is equal to f of minus 5 into f of minus 5. This is equal to 1 by 4 into 1 by 4, which is equal to 1 by 16. So f of minus 10 is equal to 1 by 16, f of 10 is equal to 16, and we are asked to calculate the value of f of 10 minus f of minus 10. So the required answer will be 16 minus 1 by 16. If you express this in decimals, this will equal 15.9375. That is the answer. In this question, we are told that f of x is equal to x square plus ax plus b, and g of x is equal to f of x plus 1 minus f of x minus 1. It is also given that f of x, which is a quadratic equation, is always greater than or equal to 0 for all real x. We are told the value of g of 20 is equal to 72, and we are required to find out the smallest possible value of b. If you are given a quadratic equation which is of the form ax square plus bx plus c, and if you are told that this quadratic equation is always greater than or equal to 0, what it is implied is that b square minus 4ac is less than or equal to 0. This is the discriminant, and if the discriminant is negative, then the given quadratic equation will have no real roots. If you are told that the given quadratic equation is always greater than or equal to 0, it is implied that the discriminant is less than or equal to 0. So in this particular case, what is the discriminant of x square plus ax plus b? It will be equal to a square minus 4b. So a square minus 4b is less than or equal to 0, or the value of b is always greater than or equal to a square divided by 4. Now we are told that g of x is equal to f of x plus 1 minus f of x minus 1. What is the value of f of x plus 1? This is equal to x plus 1 whole square plus a into x plus 1 plus b. And what is the value of f of x minus 1? This is equal to x minus 1 whole square plus a into x minus 1 plus b. If you are subtracting one from the other, that is f of x plus 1 minus f of x minus 1, this is equal to g of x. This is equal to x plus 1 minus x minus 1 whole square, that is equal to 4x plus ax plus 1 minus a of x minus 1. So this will equal plus 2a, and b will get cancelled. So g of x is equal to 4x plus 2a. We are told that g of 20 is equal to 70. So the value of g of 20 is equal to 4 times 20 plus 2a, or this is equal to 2a plus 80. This we are told is equal to 72, or the value of a is equal to minus 8 divided by 2, which is equal to minus 4. Now we are asked to find out the smallest possible value of b. We know that b is always greater than or equal to a square by 4, and the value of a is minus 4. So b is always greater than or equal to minus 4 whole square, that is 16 divided by 4, which is equal to 4. Hence the smallest possible value of b is 4. In this question, we are told that there is a group of 10 students and the mean of the lowest 9 is 42, while the mean of the highest 9 is 47. So let us assume that when you arrange the scores in ascending order, the scores are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. What is told to us is that the mean of the lowest 9 is equal to 42. So what is the sum of these 49 scores? This 9 scores, it will be 42 into 9, which is equal to 378. And the mean of the highest 9 is 47. So if you sum up the highest 9 scores, the sum will be equal to 47 into 9. What is the value of 47 into 9? That will be 470 minus 47, which is equal to 423. So this is equal to 423. Or essentially what it is being told is that the highest score minus the lowest score will equal 423 minus 378. That is, the highest score minus the lowest score is equal to 423 minus 378, which is equal to 45. Now we are told that for the group of all the 10 students, what is the maximum possible score and what is the minimum possible score and what is the difference between those two. So we know that the 10th highest score minus the least highest score is equal to 45, or the 10th highest score is equal to 45 plus the least highest score. Now, what is the minimum value of the least highest score? First, let us try to calculate the maximum value. Because the mean of the smallest 9 is equal to 42, the lowest score cannot exceed 42. Because if it exceeds 42, all the scores which are above it will also be greater than 42, and hence the mean itself will be greater than 42. The maximum possible value of the least score is equal to 42. So, the maximum possible value of the highest score is equal to 42 plus 45, which is equal to 87. Therefore, what is the maximum possible value of the sum? The maximum possible value of all the 10 scores will be equal to 378, which is the sum of the lowest 9 scores, plus 87. So, that will be equal to 465, and the maximum value of the average is equal to 46.5. Now, let us try to identify what is the minimum possible sum and minimum possible average. If you are trying to find out the minimum possible sum for the 10th highest score or the highest score, you know that the sum of the average of the highest 9 scores is equal to 47. So, the 10th highest score cannot be equal to, or basically the highest score cannot be less than 47. Because if this score is less than 47, then all the scores to the left of it will also be less than 47, and hence the sum of all of these scores will also be less than 47. The average will be less than 47. This is not possible. So, the minimum possible value of the highest score will equal 47. And in this case, what is the minimum possible value of the lowest score? That will be 47 minus 45, which is equal to 2. And in this particular case, what is the minimum value of the sum? The minimum value of the sum, again like we have done earlier, will be 378, which is the sum of the 9 scores which are other than the highest, plus the minimum value of the 10th highest score, which is equal to 47. This is equal to 425, and the average min will equal 425 divided by 10, which is 42.5. So, if you are looking for the difference between the mean of the maximum possible mean minus the minimum possible mean, that is 46.5 minus 42.5, which is equal to 4. In this question, we are asked to find out the number of integers that satisfy the equation x square minus 5x plus 7 to the power x plus 1 is equal to 1. If x is an integer, x square minus 5x plus 7 is an integer, and x plus 1 is also an integer. So, this is of the form a to the power b is equal to 1, where both a and b are integers. So, now you have 3 cases. The first case is that b is equal to 0, that is the number in the exponent is equal to 0. The second case is that a is equal to 1, that is the number as the base is equal to 1, and the third case is that a is equal to minus 1 and b is an even number. These are the 3 cases that are possible. Let us look at the first case where the number in the exponent is equal to 0. That would imply that x plus 1 is equal to 0, or the value of x is equal to minus 1. Let us look at the second case where the number in the base is equal to 1. That would imply x square minus 5x plus 7 is equal to 1, or x square minus 5x plus 6 is equal to 0. This is x minus 2 into x minus 3 is equal to 0. So, the value of x is equal to 2 or 3. Let us look at the last case where a is equal to minus 1 and the number in the exponent is an even number. If a is equal to minus 1, it would imply that x square minus 5x plus 7 is equal to minus 1, or x square minus 5x plus 8 is equal to 0. But this quadratic equation will not have any real roots. Why does it have no real roots? Because the number b square minus 4ac, that is the discriminant, is less than 0. In a quadratic equation of the form ax square plus bx plus c is equal to 0, for this quadratic equation to have real roots, you want the discriminant, that is b square minus 4ac, should be greater than or equal to 0. Only then will this quadratic equation have real roots. In this particular case, b square is minus 5 square minus 4 into 8 into 1. This is equal to 25 minus 32, which is equal to minus 7, which is less than 0. So, this quadratic equation has no real roots. So, there are no roots in the third case. So, the total number of integral roots for the given quadratic equation are x is equal to minus 1 or 2 or 3. So there are 3 real roots. In this question, we are told to find out the number of pairs of integers x and y such that x is greater than or equal to y is greater than or equal to minus 20 and 2x plus 5y is equal to 99. So let us try to first figure out what are the boundaries for y. So in this case, we are told that x is greater than or equal to y and 2x plus 5y is equal to 99. So if 2x plus 5y is equal to 99 and x is greater than or equal to y, if we replace y in place of x over here, 2y plus 5y will be less than or equal to 2x plus 5y because y is less than or equal to y. So 7y will be less than or equal to 99, or y will be less than or equal to 99 divided by 7, which is equal to just 14.14, but because y is an integer, y will be less than or equal to 14. We also know that y it is given to us is greater than or equal to 20. So the list of numbers that y can take is from minus 20 to minus 14, but can take all those values. We will notice that 2x is equal to 99 minus 5y. So if y is even, then 5y will be even and 99 minus 5y will be odd, but the value of 2x will always be even. So you want 99 minus 5y to be even, therefore 5y has to be odd, or y itself has to be odd. Therefore we have to find out all the odd integers which lie between minus 20 to 14, and for each such value of y we will find a unique value for x. And what are all the odd integers between minus 20 and 14? If you are looking at the odd integers which are negative in value, there will be minus 19, minus 17, minus 15, dot dot dot, minus 1. There are 10 such values for y, and if you are looking for positive values of y, there will be 1, 3, 5, 7, 9, 11, 13. This is 7. So the total number of values that y can take are 10 plus 7, which is equal to 17. And for each such value of y, we will be able to find a integral value for x. So the correct answer is 17. In this question, we are told that in May, John bought the same amount of rice and wheat that he had bought in April, but he had to pay 150 more because the price of rice increased by 20% and the price of wheat increased by 12%. So he bought some rice and he bought some wheat. Let us assume that in April, the amount of rice that he bought in both the months, because he bought the same, it is say A kgs and B kgs. Let us assume that the price of rice in April is X and the price of wheat in April is Y. Therefore, what is the price of rice in May? In May, it increased by 20%. So this becomes equal to 1.2x and wheat will become 1.12y. So what is the total amount of money that he spent on rice in April? That will be AX. And the total amount of money that he spent on wheat will be plus by. This is the total amount of money that he spent in April. Similarly, the total amount of money that he spent in May would be equal to 1.2 AX plus 1.12 by. The difference between these two is given to be equal to 150. For the value of 0.2 AX plus 0.12 by is equal to 150. What is told to us is that the amount of money that he spent on rice in April is equal to 450, or the value of AX is equal to 450. Therefore, what is the value of 0.2 into AX? That will be 450 into 0.2, which is equal to 90. So this is equal to 90, which would imply that 0.12 into by, this will equal 60. That is 150 minus 90. If 0.12 into by is equal to 60, the value of by will equal 500. That is 60 divided by 0.12. This is the amount of money that he spent on wheat in April. What we are asked to find out is the amount of money that he spent on wheat in May. So that will equal 500 into 1.12, which is equal to 560. So the answer in this case is 560. In this question, we are told that x and y are non-negative integers such that x plus 9 is equal to z and y plus 1 is equal to z. So let us assume that the three numbers are x, y and z. If we assume that x is equal to x, the value of z will become equal to x plus 9, and this would imply that y, which is just one number less than z, will become equal to x plus 8. So you have three numbers x, x plus 8 and x plus 9, and we are told that x plus y is less than z plus 5. So x plus, what is the value of y? That will become equal to x plus 8, is less than z plus 5. The value of z is x plus 9. So this is less than x plus 9 plus 5. We can cancel x on both sides. So x plus 8 is less than 14 or x is less than 6. We know that x is a non-negative integer, so the values that x can take will be 0 or 1 or 2 or 3 or 4 or 5. These are the values that x can take because x is non-negative, so it has to be greater than or equal to 0 and x is less than 6. Now we are required to find out the maximum possible value of 2x plus y. What is the value of 2x plus y? It will be equal to 2x plus y, but y is equal to x plus 8. So this will be equal to 2x plus x plus 8, which is equal to 3x plus 8. We are required to find out the maximum possible value of this, where x can be any number between 0 and 5. So for this to be the maximum value, x has to be maximized, or the value of x will be equal to 5. Therefore 3x will be 15 and 15 plus 8 is 23. So the correct answer is 23. In this question we are told that Aaron bought some pencils and sharpeners, and spending the same amount of money as Aaron, Aditya bought twice as many pencils and 10 less sharpeners. So there is Aaron, there are pencils and there are sharpeners. So let us assume that Aaron has bought A amount of pencils and B amount of sharpeners, and let Aditya buy, because he bought twice as many pencils, he has bought 2A number of pencils and B minus 10 sharpeners. Now let us assume it is also given that the cost of one sharpener is 2 rupees more than the cost of a pencil. So let us assume that the cost of a pencil is x, therefore the cost of a sharpener will be x plus 2. Therefore what is the total amount of money spent by Aaron? It will be the number of pencils he bought into the price of a pencil, which is ax, plus the number of sharpeners he bought into the price of a sharpener, that is b into x plus 2. This is the same as the amount of money spent by Aditya. So that will equal 2a into x plus b minus 10, which is the number of sharpeners that he bought, into the price of a sharpener, which is x plus 2. So if you expand on both sides, you can cancel 1a of x, and this 2a of x will become equal to ax, and b into x plus 2 will become equal to bx plus 2b, and on the right hand side this will become equal to plus b minus 10 into x plus 2 is bx minus 10x plus 2b minus 20. You can cancel bx on both sides, you can cancel 2b on both sides. Therefore the value of ax minus 10x is equal to 20. Or if you are trying to find out the value of a will equal 20 divided by x plus 10, where x, as we have assumed, is the price of a pencil. Now what we are required to calculate is the minimum possible number of pencils that are bought by Aaron and Aditya together. Aaron bought a number of pencils and Aditya bought 2a number of pencils. So the total number of pencils bought by both of them is equal to 3a, and we are trying to minimize this. So to minimize 3a, we have to minimize a. So what is the minimum possible value of a? Because a is equal to 20 by x plus 10, the value of x has to equal 20, which is the largest factor of 20. So the minimum possible value of a will equal 20 by x, which is equal to 1, plus 10, which is equal to 11. So the minimum possible number of a is 11. So the minimum possible value of 3a will equal 33. That is the answer.
We at Kraku provide all the previous year CAT papers along with many other MBA examinations such as IIFT, ZAT, SNAP, MAT, CMAT, TIS and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.
In this question, we are asked to find out the maximum possible value of x divided by square root of 1 plus x to the power 4. We are told that x is a real number. So let us assume that the given expression is equal to y. So y, we are supposed to calculate the maximum possible value, where y is equal to x divided by square root of 1 plus x to the power 4. In order to remove the square root in the denominator, let us square both the sides. So y square is equal to x square by 1 plus x to the power 4. And we are required to calculate the maximum possible value of y. If you are looking at the right hand side, it is x square divided by 1 plus x to the power 4. So let us divide the numerator and denominator by x square. So this becomes equal to 1 by x square plus x square. If you're looking just at the denominator, which is equal to x square plus 1 by x square is always a positive number. So x square plus 1 by x square divided by 2 is always greater than or equal to square root of x square into 1 by x square, which is equal to 1. This is the arithmetic mean is greater than or equal to geometric mean. So x square plus 1 by x square is always greater than or equal to 2. So if you divide this or take the reciprocal on both sides, 1 by x square plus 1 by x square, this will always be less than or equal to 1 by 2. Or in the given expression, y square will always be less than or equal to 1 by 2, or y itself will always be less than or equal to 1 by square root of 2. Therefore, the maximum value of y will be equal to 1 by square root of 2. In this question, we are asked to find out the number of ways we can get a pair of integers x comma a. They can be chosen such that x square minus 2 modulus of x plus modulus of a minus 2 is equal to 0. Note that x and a are integers. They can be both positive as well as negative. So what we'll do is quite simple. We'll assume that modulus of x is equal to y. So y is greater than or equal to 0. And we'll assume modulus of a minus 2 is equal to p, which is also greater than or equal to 0. Then we'll try to find out the different values for y and p which satisfy the given equation, and based on it we'll find out the different values of x and a which will satisfy the same equation. So in terms of y, the given equation will transform to y square minus 2y plus p is equal to 0. We have p which is greater than or equal to 0, and we have y which is greater than or equal to 0. This is a quadratic equation, and for the quadratic equation to have real roots, the discriminant should be greater than or equal to 0. The discriminant is the coefficient of y whole square, that is 4, minus 4 times the constant term which is p into the coefficient of y square. So 4 minus 4p should be greater than or equal to 0, or p should be less than or equal to 1. Note that in any quadratic equation which is of the form ax square plus bx plus c is equal to 0, this quadratic equation will have real roots if and only if b square minus 4ac is greater than or equal to 0. Therefore, we want p to be less than or equal to 1. So now we have two cases. P is both an integer, and as we have discussed earlier, p has to be greater than or equal to 0. So the first case is that p is exactly equal to 0, and the second case is that p is exactly equal to 1. These are the only two positive integers for which will satisfy the fact that modulus of a minus 2 is greater than or equal to 0. If p is equal to 0, modulus of a minus 2 is equal to 0, or a minus 2 is equal to 0, or a will be exactly equal to 2. Now what is the possible values for x? If p is equal to 0, then y square minus 2y is equal to 0, or the value of y is equal to 2, or y is equal to 0. If y is equal to 0, it would imply that modulus of x is equal to 0, or x will equal 0. If y is equal to 2, it would imply that modulus of x is equal to 2. So x can be either 2 or x can be equal to minus 2. So in this particular scenario, what are the total possible cases? X can take any one of these three values, and a can take exactly one value. So the total number of cases is 3 in this particular scenario. Let us look at the second case where p is equal to 1. If p is equal to 1, then modulus of a minus 2 is equal to 1, or a minus 2 is either equal to 1 or a minus 2 is equal to minus 1. Therefore, a is either equal to 3 or a is equal to 1. So here we have two possible values for a. Now what is the scenario for x? If p is equal to 1, y square minus 2y plus 1 is equal to 0, or y minus 1 whole square is equal to 0, or y will exactly equal 1. If y is equal to 1, modulus of x is equal to 1. So the value of x is either 1 or x is equal to minus 1. So x can take two values, it can be either 1 or minus 1. Similarly, a can take two values, it can be either 3 or 1. So the total number of cases in this particular scenario is 2 into 2, that is 4 cases. So what are the total number of ordered pairs that are possible? It will be 3 plus 4, which is equal to 7 cases. So the correct answer is 7. In this question, we are told that x and y are two positive real numbers such that x plus y is equal to 102, and we are asked to calculate the minimum possible value of 2601 into 1 plus x into 1 plus y. So if you are looking at the expression for which we have to find the minimum possible value, we have to find the minimum possible value for 2601 into 1 plus 1 by x into 1 plus 1 by y. As 2601 is a constant, we can ignore it for the sake of calculating the minimum. We'll first try to identify at what value of x and y this minimum occurs. So for that we can ignore 2601. We'll just focus on 1 plus 1 by x into 1 plus 1 by y. So over here, if you expand this, this will be equal to 1 plus 1 by x plus 1 by y plus 1 by x into y. So we are required to find out for what value of x and y this expression attains its minimum. Again, we can ignore 1 because it's a constant. So let us focus only on 1 by x plus 1 by y plus 1 by x into y. So over here, the common denominator for this will be x into y. So 1 by x plus 1 by y plus 1 by xy is equal to x plus y plus 1. So we are required to find out the minimum possible value of this. We'll try to figure out at what value of x and y this happens. X plus y is a constant which is equal to 1 or 2. So the numerator will be equal to 103 by x into y. So we have to figure out at what value of x and y this attains its minimum, or basically we have to figure out the value of x and y at which x into y attains its maximum. Because x into y is in the denominator in the minimum expression, if we bring it to the numerator, we will have to find out the value of x and y for which x into y attains its maximum value. We know that the sum x plus y is equal to 1 or 2, which is a constant. Therefore, the product x into y will attain its maximum when x is equal to y is equal to 51. Why is this the case? Because x and y are positive real numbers, so we can use the arithmetic mean is greater than or equal to geometric mean theorem. So x plus y divided by 2 is always greater than or equal to square root of xy, or square root of xy is always less than or equal to x plus y is 1 or 2 by 2, which is 51, and this equality will occur when x is equal to y. So x is equal to y is equal to 51 is when x into y attains its maximum. Therefore, this expression 1 plus 1 by x plus 1 by y plus 1 by xy attains its minimum. So what is the value of the given expression when x is equal to y is equal to 51? That will equal 2601 into 1 plus 1 by 51 into 1 plus 1 by 51. This is equal to 2601 into 52 by 51 into 52 by 51. 2601 is 51 square, so you can cancel these two. So this is equal to 52 square, which is equal to 2704. This is the answer.
In this question, we are told that a basket of 2 apples plus 4 oranges plus 6 mangoes costs the same as a basket of 1 apple plus 4 oranges plus 8 mangoes. And this costs the same as a basket of 8 oranges and 7 mangoes. We are asked to calculate how many mangoes can a basket which is consisting only of mangoes fit in a basket which costs the same as each of these 3 baskets. So basically we are given 2 equations. This is one equation and this is another equation, and there are 3 unknowns. The 3 unknowns are apples cost, orange cost and mangoes cost. So we are going to find out the value of how much an apple will cost in terms of mangoes and how much an orange will cost in terms of mangoes. Then we will convert the price of each of these baskets into mangoes. Then we will get the answer. So if you are equating the first 2 equations, first 2 expressions, if 2a plus 4o plus 6m is equal to a plus 4o plus 8m, we can cancel 4o on both sides. So 2a plus 6m will equal a plus 8m, or the value of a is equal to 2m. So the price of 1 apple is equal to the price of 2 mangoes. Similarly, if you are equating the second 2, the last 2 expressions, we can cancel 4o. So a plus m will be equal to 4o. But we know that a is equal to 2m. So 2m plus m is equal to 4o, or the value of o is equal to 3 by 4m. So we have found out the value of how much a orange will cost in terms of mangoes. We have found out how much an apple costs in terms of mangoes. So we can convert any one of the 3 expressions. The number of mangoes will be the same. If you are looking at, say, the first expression, 2a will be equal to 4m plus 4O will be equal to 4 into 3 by 4, so 3M plus 6M. This is the cost of the first basket in terms of mangoes, so this is equal to 13 mangoes. So the correct answer is option B, which is 13. In this question, we are given an inequality which says that modulus of n minus 60 is less than modulus of n minus 100 is less than modulus of n minus 20, and we are asked to calculate how many integers n satisfy this given inequality. If you are looking at the inequality, there are 3 modulus in it, and each of the modulus will have an inflection point. That is the point at which the modulus will change its sign. The first one is at 60, the second one is at 100, and the third one is at 20. So let us consider 4 cases. The first case is when n is less than 20. The second case is when n lies between 20 and 60. The next case is when n lies between 60 and 100. And the last case is when n is greater than 100. Because we have to look for even the inflection points at 20, 60 and 100. In the first one we will include 20, in the second one we will include 60, and in the third one we will include 100. Now if you are looking at the first interval when n is less than or equal to 20, then the value of modulus of n minus 20 will be 20 minus n. And the value of modulus of n minus 100 will be 100 minus n. And the value of the modulus of n minus 60 will be 60 minus n, because n is less than 20. So the given inequality will transform to become equal to 60 minus n is less than 100 minus n. This is the first part of the inequality. And we want the second inequality also to be true, which is that 100 minus n should be less than 20 minus n. If you are simplifying the first part, we can cancel minus n from both sides. So we want 60 to be less than 100, which is true. And we want, again we will cancel minus n from both sides, and we want 100 to be less than 20. This is not true. So both the inequalities should be true in this interval, which is not happening. So there will be no value of n which is less than or equal to 20 for which these two inequalities will be true. That is, modulus of n minus 60 is less than modulus of n minus 100, as well as modulus of n minus 100 being less than modulus of n minus 20. Let us look at the second interval. In the second interval, 20 is less than n is less than or equal to 60. If 20 is less than n, the value of modulus of n minus 20 will be n minus 20. The value of modulus of n minus 100 will be 100 minus n, and the value of modulus of n minus 60 will be 60 minus n. So the given inequality will become equal to 60 minus n is less than 100 minus n, and 100 minus n is less than n minus 20. Both of these should be true. The first inequality can be simplified to equal 60 is less than 100, which is always true. And the second inequality would imply that 120 is less than 2n, or the value of 60 is less than n. But in this interval, we assumed that n is lying between 20 and 60. N is not greater than 60. So again, there will be no value of n which lies between 20 and 60 such that both of these given inequalities will be true. Let us look at the third interval. In this case, modulus of n minus 60 will be n minus 60. Modulus of n minus 100 will be 100 minus n, and modulus of n minus 20 will be n minus 20. So the first part of the inequality will be that n minus 60 is less than 100 minus n, and the second part is that 100 minus n is less than n minus 20. The first part can be simplified to equal 2n is less than 160, and the second part can be simplified to equal 2n is greater than 120. Or basically we want n to be less than 80 and we want n to be greater than 60. In the given interval where n is lying between 60 and 100, there are some integers which lie between 60 and 80, and they are 61, 62, ... till 79. So there are 19 such integers in this interval. Let us look at the last interval where n is greater than 100. If n is greater than 100, the values of all of these modulus will become very easy. Value of modulus of n minus 100 is n minus 100, value of modulus of n minus 60 is n minus 60, and value of modulus of n minus 20 is n minus 20. So in this particular case, the two inequalities are n minus 60 is less than n minus 100, and n minus 100 is less than n minus 20. We can cancel n. So we want minus 60 to be less than minus 100, which is not true. because minus 60 is actually greater than minus 100. So the first part of this inequality is not true whenever n is greater than 100. In the second part, minus 100 is actually less than minus 20. This is true, but we know that the first part is not true. So both the inequalities are never satisfied whenever n is greater than 100. So the only set of integers which satisfy this given inequality, this whole inequality, lie between 60 and 80, and there are 19 such integers. They are 61, 62, ... till 79. So the correct answer is option B. In this question, we are told that hospital A admitted 21 COVID patients less than hospital B. So this is hospital A and this is hospital B. Let us assume that the number of admissions in hospital A is X. So the number of admissions in hospital B will be X plus 21. Let us assume that the average recovery time, there is some information given about that also. The average recovery time in hospital A was 3 days more than that of hospital B. So let us assume that the number of average days of recovery in hospital B is A. So the average recovery days in hospital A is A plus 3. We are told that the total recovery days in hospital A is 200. So that would imply that X into A plus 3 is 200. And total recovery days in hospital B is 152. So X plus 21 into A is 152. What this implies is that X into A plus 3 is equal to 200, while X plus 21 into A is equal to 152. We are required to calculate the number of people who are admitted in hospital A. So we are required to calculate the value of X. So let us try to eliminate A. The value of A is equal to 152 divided by X plus 21 from the second equation. We will substitute that in the first equation. So X into 152 divided by X plus 21 plus 3 is equal to 200, or X into 152 plus 3X plus 63 is equal to 200 into X plus 21. This would imply that X into 3X plus 215 is equal to 200 into X plus 21. So 3X square plus 215X is equal to 200X plus 4200, or 3X square plus 15X minus 4200 is equal to 0. If you divide the entire equation by 3, X square plus 5X minus 1400 is equal to 0. This is a quadratic equation which can be factorized to equal X plus 40 into X minus 35 is equal to 0. So the value of X is either equal to minus 40 or the value of X is equal to 35. So the required equation is that the number of patients who are admitted in hospital A, which is equal to X, is equal to 35. That will be the answer. In this question, we are told that f of x is x square plus 2x minus 15 divided by x square minus 7x minus 18, and we want to find out when f of x is negative. What are the intervals of x for which f of x is negative? If you are looking at f of x, it is the numerator is x square plus 2x minus 15. This can be factorized to equal x plus 5 into x minus 3. And the denominator is x square minus 7x minus 18. This can be factorized to equal x minus 9 into x plus 2. So what we are required to calculate is the values of x for which x plus 5 into x minus 3 divided by x plus 2 into x minus 9. This has to be less than 0. If you multiply the both sides, the left hand side and the right hand side, with x plus 2 into x minus 9 whole square, that will be a positive number because it is a perfect square, and the right hand side will be 0 into x plus 2 into x minus 9 whole square, so that will remain 0, and the left hand side, basically the denominator comes to the numerator. So it can be simplified to equal x plus 5 into x minus 3, which is the numerator, into x plus 2 into x minus 9. We want to know for what values of x this is less than 0. Now if you are looking at this expression, what are the roots of this expression? The roots are minus 5, 3, minus 2 and 9. So let us draw the number line. This is the number line and let us plot the 4 roots. The smallest root is minus 5, this will come over here. The second smallest root is minus 2, we have minus 5, we have minus 2. Then we are going to get 3 and finally we are going to get 9. If the value of x is greater than 9, all of these 4 terms will be positive. If you are assuming that the value of x is say 10, 10 plus 5 is 15, 10 minus 3 is 7, 10 plus 2 is 12 and 10 minus 9 is 1. All of them are positive. So their product will be positive. If x is lying between 3 and 9, let us assume that the value of x is say 5. Then x plus 5 will be positive, 5 plus 5 will be 10. X minus 3 will be positive, 5 minus 3 is 2. X plus 2 will be positive, 5 plus 2 is 7. But x minus 9 will be negative, 5 minus 9 is minus 4. So here we are getting the product of 3 positive numbers and 1 negative number. So this is negative. And the sign keeps alternating. If x is lying between minus 2 and 3, the sign will be positive. Because 2 of the terms will be positive and 2 of the terms will be negative. The 2 positive terms will be x plus 5 and x plus 2. The 2 negative terms will be x minus 3 and x minus 9. The product of 2 positive terms and 2 negative terms is positive. Then we are going to get negative over here if x is lying between minus 5 and minus 2, because only one term x plus 5 will be positive, all the 3 remaining terms will be negative. And if x is less than minus 5, again it will be positive. Because all the 4 terms will be negative, the product of 4 negative terms will be positive. So if you are looking for this expression to be less than 0, x has to either lie between minus 2 and minus 5 or it has to lie between 3 and 9. So the correct answer is option A. In this question, we are given a quadratic equation which involves a modulus and we are asked to calculate the value of r for which this quadratic equation has exactly 3 distinct real roots. Now, if you are looking at the equation, because this involves modulus, the left hand side is always greater than or equal to 0. This would imply that r itself has to be greater than or equal to 0. The second thing is, if you are removing the modulus, the sign will change. So either x square minus 4x minus 13 is either equal to r, or if x square minus 4x minus 13 is actually negative, then it would imply that x square minus 4x minus 13 is equal to minus r. Both of these cases are possible. If you are simplifying the first case, it would imply that x square minus 4x minus 13 minus r is equal to 0, or in the second case, x square minus 4x minus 13 plus r is equal to 0. Every quadratic equation has a discriminant. If you are assuming that the quadratic equation is of the form ax square plus bx plus c is equal to 0, the value of the discriminant d is equal to b square minus 4ac. And if this d is greater than 0, the given quadratic equation will have 2 real roots. If the value of the discriminant d is equal to 0, it will have one distinct real root. And if the value of this discriminant d is less than 0, it would imply that there are no real roots. Let us calculate the discriminant for both of these quadratic equations. If you are looking at the discriminant 1, which is d1, this will be equal to b square. So minus 4 whole square is 16 minus 4 times minus 13 minus r. Or you can simplify this, this will be equal to 68 plus 4r. This is the first discriminant. If you are looking at the discriminant of the second quadratic equation, this is equal to minus 4 whole square. So again 16 minus 4 times minus 13 plus r. This will be equal to 68 minus 4r. These are the two discriminants of the two quadratic equations. We know that r is greater than or equal to 0. So this sum 68 plus 4r is strictly greater than 0. This is greater than or equal to 68, which is basically greater than 0. So the first quadratic equation will definitely have 2 real roots. This would imply that the second quadratic equation should have strictly one real root, one distinct real root. How is that going to happen? It would happen if this discriminant is actually equal to 0. In that particular case, this quadratic equation will have one distinct real root. So 68 minus 4r has to equal 0, or the value of r has to equal 17. So the answer for this question is option A, which is 17. In this question, we are given a quadratic equation ax square minus bx plus c, and we are told that one of the roots of this quadratic equation is 2 plus square root of 3, and we are told that a, b and c are rational numbers. So we know that the quadratic equation is ax square minus bx plus c is equal to 0. This would imply that the sum of the roots of this quadratic equation will be b by a. And the product of the roots of this quadratic equation is c by a. Now, because a, b and c are all rational numbers, b by a is rational, c by a is rational. But one of the roots is 2 plus square root of 3. As the sum of the roots and the product of the roots of this quadratic equation are rational numbers, this would imply that the second root has to be 2 minus square root of 3. 2 minus square root of 3 is the conjugate of 2 plus square root of 3. So, both of them have to be the roots of a given quadratic equation. Otherwise, a, b and c will not be rational. You can even prove it. We can even prove it now, but you can just understand this and take it for granted. If you are looking for the proof, because the sum of the roots is 2 plus, because the sum of the roots is rational, and if one of the root is 2 plus square root of 3, the other root has to be of the form x minus square root of 3, because you want square root of 3 to get cancelled in the sum of the roots, which is a rational number, and square root of 3 is irrational. Now if you are assuming the other root to be x minus square root of 3, what is the product of roots? It is x minus square root of 3 into 2 plus square root of 3, which would be 2x minus 2 square root of 3 plus x square root of 3 minus square root of 3 into plus square root of 3, which is 3. 2x minus 3 will be a rational number, so we will ignore it. We want this term to be equal to 0, because this term contains square root of 3, which is an irrational number. So we want square root of 3 into x minus 2 to be equal to 0, or you want x to be equal to 2. Now this is the proof for what we have already determined, which is that the other root has to be x minus square root of 3, where x is 2, or that the other root has to be 2 minus square root of 3. Now if one root is 2 plus square root of 3 and the other root is 2 minus square root of 3, what is the sum of the roots? The sum of the roots, which is b by a, is equal to 4. And what is the product of the roots? That is, what is c by a? That will be equal to the product of 2 plus square root of 3 into 2 minus square root of 3, which is equal to 2 square minus square root of 3 whole square, which is 4 minus 3, which is equal to 1. So c by a will be equal to 1, or the value of b by c is equal to 4. We are told that b is equal to c cube. So b by c will be equal to c square. This is equal to 4. So the value of c is either equal to plus or minus 2. C by a is equal to 1. So the value of a also is plus or minus 2. We are asked to calculate the value of modulus of a. So the value of modulus of a will be equal to 2. So the answer for this question is 2. In this question, we are asked to calculate the range of the function f of x for all real values of x. If you are looking at the function, the numerator is x square plus 2x plus 4 and the denominator is 2x square plus 4x plus 9. So clearly 2 times the numerator will be equal to 2x square plus 4x plus 8. So the denominator is basically 2 times the numerator plus 1. So to make things easy, let us find the range of the function 1 by f of x. 1 by f of x is equal to 2x square plus 4x plus 9 divided by x square plus 2x plus 4. Like we have discussed earlier, this is equal to 2 plus 1 by x square plus 2x plus 4. This is 1 by f of x. Now this number, this expression can be simplified because x square plus 2x plus 4 is equal to x plus 1 whole square plus 3. So 1 by f of x can be simplified further to equal 2 plus 1 divided by x plus 1 whole square plus 3. What is the range of this function? The range of this function is dependent on the value of x. Now if you are just considering x plus 1 whole square plus 3, x plus 1 whole square plus 3 is always greater than or equal to 3. And it is going to equal 3 when x is equal to minus 1, because this is a perfect square. X plus 1 whole square is a perfect square. So 1 by x plus 1 whole square plus 3 is always less than or equal to 1 by 3. Similarly, x plus 1 whole square plus 3, the minimum value is 3 and the maximum value, there is no limit for it. The maximum value can be any number. It can be 1 lakh, 10 lakhs, 1 crore. It can become very, very large. It can become essentially equal to infinity. So the value of 1 plus x plus 1 whole square plus 3 is basically greater than 0. For any value of x, you make x to be a very large number, then 1 plus 1 divided by x plus 1 whole square plus 3 will become very large, but it will not equal 0. It will be some number which is just greater than 0. So now if you are looking at 1 by f of x, the range of 2 plus 1 by x plus 1 whole square plus 3 is always greater than 2, because the second term of this expression is always greater than 0, and this is always less than or equal to 2 plus 1 by 3. What is 2 plus 1 by 3? That is equal to 7 by 3. So the range of 1 by f of x is between 2 to 7 by 3. It will touch 7 by 3 when x is equal to minus 1, and it will never touch 2. That is, it can never be equal to 2. But it will become very, very close to 2 as the value of x becomes very, very large. This is the range of 1 by f of x. So what is the range of f of x? The range of f of x is just the reciprocals, which is 3 by 7 to 1 by 2. So the correct answer will be option D. The value of f of x will equal 3 by 7 when x is equal to minus 1. But the value of f of x will not be equal to 1 by 2. It will just become very close to 1 by 2 as the value of x becomes very, very large. So the correct answer is option D.
Google search Krakow CAT formulas PDF. Click on the first link. You will get a list of topics for CAT. Click on one of the topics. Download the PDF to get a list of formulas for the topic.
In this question, we are told to find out for a real number x, we have been given an equation which is that modulus of 3x minus 20 plus modulus of 3x minus 40 is equal to 20. This necessarily holds if x lies between what given intervals. So let us first look at the equation that is given to us. We have modulus of 3x minus 20 and modulus of 3x minus 40. So let us consider different cases. The first case to consider is that let us draw 3 cases and solve them over here. The first case is that 3x is less than 20. In the second case, 20 is less than or equal to 3x, which is less than or equal to 40. In the next case, 3x is greater than 40. If 3x is less than 20, 3x minus 20 will be negative and 3x minus 40 will also be negative. So modulus of 3x minus 20 will be 20 minus 3x plus 40 minus 3x. This is equal to 20. You cancel both of them. So you are given that 6x will be equal to 40, or the value of x will be equal to 20 divided by 3. But in this case, we are looking for 3x is less than 20, or we want the value of x to be less than 20 by 3. We don't want x to be equal to 20 by 3. So there is no value of x in this given interval for which the given equation is satisfied. In the second case, if 3x is lying between 20 and 40, both of them included, it would imply that 20 by 3 is less than or equal to x, which is less than or equal to 40 by 3. Now 3x minus 20 will be positive because 3x is greater than 20, greater than or equal to 20. So this would become equal to 3x minus 20 plus 3x minus 40 will be negative because 3x is less than or equal to 40. So the modulus of 3x minus 40 will become equal to 40 minus 3x. This is equal to 20. We can cancel plus 3x and minus 3x, and this becomes a tautology. The equation is that 20 is equal to 20, which is always true. So for all values of x which are lying between 20 by 3 and 40 by 3, both of them included, this equation is satisfied. Let us look at the last case where 3x is greater than 40 or the value of x is greater than 40 by 3. Then both of them will be true. 3x minus 20 will be positive and 3x minus 40 will also be positive. So the given equation becomes equal to 3x minus 20 plus 3x minus 40 is equal to 20, or the value of 6x is equal to 80, or the value of x is equal to 40 by 3. Again, we are looking for the values of x which are greater than 40 by 3. We are not looking for the value of x which is equal to 40 by 3. So again, we have no value of x for which x is greater than 40 by 3, for which this equation is true. So the only values of x for which this equation is true lie between 20 by 3 and 40 by 3. 20 by 3 is 6.666 and 40 by 3 is 13.333. Now if you are looking at the timeline, if you're looking at the number line like this is 0, this is 1, this is 2, similarly dot dot dot, this is 6, this is 7, dot dot dot, this is 11, this is 12, this is 13, and this is 14. We are going to get 6.66 somewhere over here, and we are going to get 13.33 somewhere over here. So for all values of x which lie between this interval, the given equation is true. If you are looking at the 4 options given to us, we are told that for all values of x which lie between 10 and 15, this equation is true. But that is not the case, because we will have some values of x which lie between 13.33 and 15, for which this equation is not true. So the first option is not correct. If you are looking at the second option, it is 9 and 14. X has to lie between 9 and 14. Now this equation is true whenever x is lying between 9 and 13.33. But you will have some values of x which lie between 13.33 and 14, for which this equation is not true. Option C is the correct answer, so we'll come to it at the end. Let us look at option D. It says that whenever x is lying between 6 and 11, this is necessarily true. But again, we can't say that for sure, because we'll have some values of x which lie between 6 and 6.66, for which this equation is not true. So this option is also not correct. If you're looking at the correct option, which is option C, it is saying that whenever x is lying between 7 and 12, so whenever x is lying between 7 and 12 over here, this equation is always true. So we can say for sure that whenever x is lying between 7 and 12, the given equation is necessarily true. So the correct answer is option C. In this question, we are given two equations. We are told that x square minus xy minus x is equal to 22 and y square minus xy plus y is equal to 34. We are told that x is greater than y, and we are asked to calculate the value of x minus y. If you are looking at the two equations, in the first equation you can take x common. So this will be x minus y minus 1 is equal to 22. And in the second equation you can take y common. So this is y into y minus x plus 1 is equal to 34. On the first glance, it looks like both the equations have nothing in common. But if you are looking at the second terms of both the equations, both of them seem quite similar. For example, if you multiply the second equation with minus 1, then it becomes equal to minus y into y minus x plus 1 is equal to minus 34. What is minus of the second term? This is y into x minus y minus 1 is equal to minus 34. Now if you are looking at this equation and this equation, both of them have x minus y minus 1 common. So if you assume that this is the first equation and this is the second equation, the first equation minus the second equation will be equal to x minus y into x minus y minus 1 is equal to 22 minus of minus 34, which is 56, because that equals 22 plus 34. Now let us assume that x minus y is equal to p. We are told that x is greater than y, so p is greater than 0. So the equation that we have will be p into p minus 1 is equal to 56, or p square minus p minus 56 is equal to 0, or p minus 8 into p plus 7 is equal to 0. So the value of p is either equal to 8 or it is equal to minus 7. We know that p is greater than 0, so the second root can be ignored. So the value of p, which is equal to x minus y, is equal to 8. So the answer for this question is option D, which is 8.
In this question, we are told that a shop owner bought 64 shirts in a wholesale market. Some of them are small and some of them are large. So S plus L is equal to 64. We are told that the price of a small one is 50 less than the price of a large one. So if you assume that the price of a small one is P, the price of a large one is P plus 50. The total money made by selling the small t-shirts is 1800. So P into S is equal to 1800. And the total money made by selling large t-shirts is 5000. So P plus 50, which is the price of a large t-shirt, into L, but L is 64 minus S, is equal to 5000. What is P? P is equal to 1800 by S. So 1800 by S plus 50 into 64 minus S is equal to 5000. We can cancel 50 from the left hand side and right hand side because both the terms of the first bracket are multiples of 50. So this would simplify to equal 36 by S plus 1
into 64 minus s is equal to 100. This is a simple quadratic equation. Let us expand the terms on the left hand side. 64 into 36 is 2304. So 2304 divided by s plus 64 minus 36 minus s is equal to 100. 100 minus 64 is 36. 36 plus 36 will be 72. Or the quadratic equation we are going to get is that s square plus 72s minus 2304 is equal to 0. S square plus 72s minus 2304 can be factorized to equal s plus 96 into s minus 24 is equal to 0. So the value of s is 24. So the person has sold 24 t-shirts and the number of large t-shirts that were sold will be 64 minus s, which is equal to 40. The price P will be equal to 1800 divided by 24. What is 1800 divided by 24? That is equal to 75. So the price of a small t-shirt is 75 and the price of a large t-shirt is P plus 50. So that is equal to 125. So the price of a small t-shirt plus the price of a large t-shirt will be 75 plus 125, which is equal to 200. That is option C.
Hi friends, welcome to Krakow's video series. In this particular question, I'll be solving this slightly difficult question that came in slot 3. This question is not an easy question. At first glance, most would actually leave this question because it involves a lot of enumeration. But let's take a look at the question. Can this question be solved without enumerating all the cases that are possible? So let's take a look at the question. The number of distinct pairs of integers m comma n satisfying modulus of 1 plus mn less than modulus of m plus n, which is less than 5, is how much? So I see there are two modulus signs and there is 5 also, and there's a strict less than condition over there. So the first thing that I'll actually do is that I'll take the square of the equation just to remove the modulus sign. So if I take the square of the equation, what do I get? 1 plus mn the whole square should be less than, because modulus sign, it gets removed when you take the square of the equation. So that should be less, and all this is positive, and 5 is also positive. So there is no changing of the inequality sign. So this should be strictly less than m plus n the whole square, which should be less than 5 square, which is 25. So if I expand this, I get 1 plus n square plus 2mn should be less than m square plus n square plus 2mn and should be less than 25. But I want to cancel off these 2mn, so I can, if I cancel this off, I get that 1 plus n square should be less than n square plus n square. So if I take all of these terms to the other side, I get 0 should be should be less than m square plus n square minus m square n square minus 1. So if I take the terms in common, what do I get? So m square minus m square n square, so I can take m square in common, so that becomes 1 minus n square, and this is n square minus 1. So if I take minus 1 in common, I can write that as 1 minus n square. So what do I get? I get that 0 should be less than m square minus 1 times 1 minus n square. But 1 minus n square and m square minus 1 doesn't look symmetric, and I want symmetric pairs as such as much as possible, so that I can just multiply it by this. Moreover, if I take this as n square minus 1, this becomes less than. So that means that m square minus 1 into n square minus 1 should be what? This should be less than 0. Now this is interesting because I am taking this, multiplying this term by minus 1, then inequality sign should flip, which means that this should be less than 0. Now this is interesting because this means that m square minus 1, one of these two terms has to be negative and the other one has to be positive. So I get two cases. The first case is case 1, which is that n square is greater than 1 and n square is less than 1. Or the second case is m square is less than 1 and n square is greater than 1. Now consider in both of these cases, these are integers, so they have to be real numbers, which mean that m square and n square have to be positive. And since they are integers, the only value that n square can take or n square can take which is less than 1 is 0 when either m or n is less than 0. So if this is the case, okay, m square is greater than 1, n square is less than 1, that means in the first case, n has to be equal to 0. Because that is the only integral value square that it can take such that it is less than 1. So if you consider minus 3, minus 4, minus 5, all of this, minus 1 onwards, the square's value will be 1 or greater. Plus 1 onwards also, all integers, it will be 1 or greater. These are integral pairs. Only m and n can take integral values. So the only way that n square is less than 1 is if n is equal to 0. Similarly, the only way that m square is less than 1 is if m is equal to 0. So essentially these two cases that I get from this particular equation is that either n is 0 or m is 0. Now in both cases, what happens to our original equation? If n is 0, what happens to our original equation? This term becomes 0. So essentially 1 has to be less than modulus of m, which has to be less than 5. Now in this case, what values can m take? M can take the values 2, 3, 4, and it can also take negative values because of the modulus. It can take minus 2, minus 3 and minus 4 as such. So m in this particular can be 2, 3, 4 or minus 2, minus 3 and minus 4. Now consider the other case where m is equal to 0. If m is equal to 0, what happens to this equation? Again this particular term becomes 0, and then again the equation becomes 1 should be less than the modulus of n, which should be less than 5. Again then in this case n is equal to 2, 3, 4 or minus 2, minus 3 and minus 4. So essentially I get, for each of the two cases, I get 6 values or 6 pairs each. So there are 12 pairs as such. When n is equal to 0, m can take 6 values. When m is equal to 0, n can take these 6 values. There is no overlap, so 6 plus 6 becomes 12. So how many distinct pairs of integers m and n are there? There are 12 such pairs of integers. Right answer to key in would have been 12. As you can see, this does not involve entire enumeration. Whenever you see a modulus, try to see whether the complexity of the equation can be reduced by just taking a square term as such. If you square both sides, maybe you can cancel something off, and then you can reduce the number of terms that you have to consider, the number of cases you have to consider. So this is how you solve this particular question.
In this question, we are told that f of x is equal to x square minus 7x and g of x is x plus 3. We are asked to calculate the value of f of g of x minus 3x. G of x is equal to x plus 3. So the value of f of g of x will be equal to f of x plus 3. But f of x is x square minus 7x. So f of x plus 3 will be x plus 3 whole square minus 7 times x plus 3. This is the value of f of g of x. What is f of g of x minus 3x? This will be x plus 3 whole square minus 7 times x plus 3 minus 3x. We are trying to find out the minimum possible value of this expression. If you are expanding this, this will be x square plus 6x plus 9 minus 7x minus 21 minus 3x. This is x square minus 4x minus 12. We are trying to find out the minimum value of this expression. If you are trying to find out the minimum value of this expression, let us try to complete a perfect square. So this is x square minus 4x plus 4 minus 4 minus 12. We have just added and subtracted 4. The reason for that is because x square minus 4x plus 4 is equal to x minus 2 whole square minus 16. We are trying to find out the minimum possible value of this particular expression. The minimum value of x minus 2 whole square is 0. Because this is a perfect square, the minimum possible value is 0 and it happens when x is equal to 2. So the minimum possible value of the given expression will be minus 16. And this happens when x is equal to 2. In this question, we are told that n is a positive integer such that 10 to the power 1 by 7 into 10 to the power 1 by 7 whole square into dot 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 into 10 to the power 1 by 7 whole to the power n is greater than 999. Remember that 999 is basically 1000 minus 1, or this is basically 10 cube minus 1. We are required to calculate the minimum possible value of n for which this inequality is true. Now if you are looking at the left hand side, this is 10 to the power 1 by 7 into 10 to the power 2 by 7 into 10 to the power 3 by 7 into dot 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 into 10 to the power n by 7. This is equal to 10 to the power 1 by 7 plus 2 by 7 plus 3 by 7 plus dot 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 plus n by 7. This can be simplified to equal 10 to the power n into n plus 1 divided by 2 whole divided by 7. So this is 14. We want this to be greater than 999. So the smallest possible value, basically because 999 is 10 cube minus 1, like we have discussed earlier, the value of n into n plus 1 by 14 has to be greater than or equal to 3, or the value of n into n plus 1 has to be greater than or equal to 42, and the minimum possible value of n for which this is true is equal to 6, because this becomes equal to 6 into 7, which is equal to 42. In this question, we are given two equations. We are told that 3x plus 2 times modulus of y plus y is equal to 7, and x plus modulus of x plus 3y is equal to 1, and we are required to calculate the value of x plus 2y. If you look at the equations, we have x, we have y, we have modulus of x, and we have modulus of y. So let us consider 4 cases. The 4 cases involve the sign of x and y. In the first case, let us assume that x is greater than 0 and y is greater than 0. In the second case, let us assume that x is greater than 0 and y is less than 0. In the third case, let us assume that x is less than 0 and y is greater than 0. And in the last case, let us assume that x is less than 0 and y is less than 0. In the first case, modulus of x will be x, modulus of y will be y. In the second case, modulus of x will remain x, but because now y is less than 0, modulus of y will be minus y. In the third case, x is less than 0, so modulus of x is equal to minus x, and modulus of y is equal to y. In the third case, both of them are less than 0, so modulus of x is equal to minus x, and modulus of y is equal to minus y. Now, if you are looking at the cases where x is less than 0, because the second equation has x plus modulus of x, we will look at the fourth case first, because then we will calculate the answers faster. Because modulus of x is equal to minus x, the second equation would transform to equal x plus modulus of x plus 3y is equal to 1. But because modulus of x is equal to minus x, x plus modulus of x will become equal to 0, or the value of y is equal to 1 by 3. So clearly the last case is not correct, because you want y to be less than 0. If you are looking at the third case, where again modulus of x is equal to minus x, or x plus modulus of x is equal to 0, again we will have 3y to be equal to 1, or the value of y is equal to 1 by 3. Y is greater than 0 over here, so this seems to be fine as of now. But let us calculate the value of x also. The first equation would imply that 3x plus 2 times modulus of y would be 2 by 3, plus y will be 1 by 3 is equal to 7, or 3x will be equal to 6, or the value of x is equal to 2. But here we are getting x to be greater than 0, but we want x to be less than 0. So this case also is disqualified. So the only two cases which are remaining are where x is greater than 0 and y is greater than 0. If you are looking at the first case, modulus of x is x and modulus of y is y. So the first equation will simplify to equal 3x plus 3y is equal to 7, and the second equation will transform to equal 2x plus 3y is equal to 1. So if you subtract the second equation from the first equation, the value of x is equal to 6, which would imply that 3x is equal to 18, or the value of 3y will be 7 minus 18, which is equal to minus 11, or the value of y is equal to minus 11 by 3. But in this case, we want x to be greater than 0 and y to be greater than 0. So this also is not true. The only case remaining is x is greater than 0 and y is less than 0. So here modulus of x is x and modulus of y is minus y. So the first equation will simplify to equal 3x minus y is equal to 7, and the second equation will simplify to equal 2x plus 3y is equal to 1. Let us multiply the first equation by 3. So 9x minus 3y is equal to 21. If you add both of them, you are going to get 11x to be 22, or the value of x will be equal to 2. If x is equal to 2, 3x will be equal to 6. So the value of y is equal to minus 1. Here x is greater than 0 and y is less than 0. So this is the solution. What are we required to calculate? We are required to calculate the value of x plus 2y. That is 2 minus 2, which is equal to 0. So the correct answer is option C. In this question, we are told that 0 is less than or equal to a, is less than or equal to x, is less than or equal to 100. We are told that f of x is modulus of x minus a plus modulus of x minus 100 plus modulus of x minus a minus 50. We are required to calculate the value of a such that the maximum value of f of x becomes equal to 100. Now, if you are looking at modulus of x minus a, because a is always less than or equal to x, this will be x minus a. Plus x is always less than or equal to 100, so this is 100 minus x. But we can't conclude anything about modulus of x minus a minus 50. So we'll write it as it is. So simplified, the value of f of x is equal to modulus of x minus a minus 50 plus 100 minus a. We are cancelling plus x and minus x. The maximum value of this, we are told, is equal to 100. The maximum value of this f of x becomes equal to 100 if the maximum value of modulus of x minus a minus 50 is equal to a. Let us look at how modulus of x minus a minus 50 looks like. How does the value of modulus of x minus p look like? This graph is actually quite simple to draw. This is a y-axis and this is x-axis. This is how modulus of x minus p looks like. When x is equal to 0, this becomes equal to p. The function becomes equal to 0 when x is equal to p, and then it will again keep on rising. In this particular case, the value of modulus of x minus a minus 50, because we can write this as modulus of x minus a plus 50. If you are just drawing this graph, it will be something like this. It will be again a V-shaped graph. It will look something like this. It will be, when x is equal to 0, this will be a plus 50. It will become equal to 0 when x is equal to a plus 50, and again it will continue to rise. But over here we are only looking for the values of x which is greater than or equal to a and x which is less than or equal to 100. So when x is actually equal to a, around here, this will equal 50. This is when x is equal to a. Because when x is equal to a, x minus a will become equal to 0 and modulus of minus 50 will become equal to 50. So we are looking at this interval from the right side of this point. So it starts with 50, it will continue to become equal to 0 when x reaches a plus 50, and again it will continue to rise. It will again rise and become equal to 50 at this point where x is equal to a plus 100. When x is equal to a plus 100, x minus a will become equal to 100. 100 minus 50 is 50. Modulus of that is 50. But you know that a plus 100 is always greater than or equal to 100 because a is greater than or equal to 0. Or essentially, for this question, because x is greater than or equal to a, the graph will be to the right of this. And because a and x, both of them are less than 100, greater than 0, it will be to the left of this. So if the maximum value of this is equal to a, it would imply that the maximum value of this, which is 50, has to be equal to a. And how does the graph look like? Let me erase all of this. Once you know that a is equal to 50, the function becomes equal to, this is again x minus a plus 100 minus x plus modulus of x minus 100. This is 100 minus a will become equal to 50. So this is 50 plus modulus of x minus 100. Here x is varying from 50 to 100 because x is greater than or equal to a, which is equal to 50. So when x is equal to 50, this will be 100 over here, and it will reach down to 0 when x is equal to a plus 50, which is equal to 100. So the maximum value is 50 at the start, like we discussed. So the value of a for this function to reach its maximum value of 100 is equal to 50. In this question, we are told that a, b, c are non-zero real numbers such that b square is less than 4ac. We are told that f of x is the quadratic equation ax square plus bx plus c, and we are told that the set S contains all the integers m such that f of m is less than 0. then this set must necessarily contain. Before we go to S, let us first look at f of x. F of x is a quadratic equation which is of the form ax square plus bx plus c. Now we know that the discriminant of this quadratic equation d is equal to b square minus 4ac. This is the discriminant. And discriminant of a quadratic equation is important to help us in figuring out what is the number of roots of this quadratic equation. If this discriminant is greater than 0, that is if b square minus 4ac is greater than 0, it will have two roots, two real roots, who are both the roots will be distinct. If d is equal to 0, both the roots will be the same and it will have essentially one unique root. If discriminant is less than 0, which is the particular case in this question, that is b square minus 4ac is less than 0, it will have 0 real roots. What is the meaning of real roots? It is basically the intersection of this function f of x and the x-axis. That is, if you have a quadratic equation, if this is the y-axis and this is the x-axis, this quadratic equation will have two roots. These are the two roots. This quadratic equation which is touching the x-axis will have just one root. This quadratic equation on the other hand, which is not touching the x-axis, will have no unique roots. That is, in this particular case, the discriminant is less than 0. In this case, the discriminant is equal to 0. And in this case, the discriminant is greater than 0. In this particular case, we are told that the discriminant is less than 0. So f of x will not intersect with the x-axis. But based on the sign of a, it is either always greater than 0 or it is always less than 0. That is, if you have the y-axis and x-axis over here, if a is greater than 0, then this is how f of x will look like. If a is less than 0, this is how the quadratic equation will look like. So in the particular case, in the first case where a is greater than 0, the set S will be empty. It will have no integers for which this f of x is actually less than 0 or f of m is less than 0. In the second case, S will have all integers, because for all values of m, f of x is less than 0. So based on the sign of a, we can figure out whether this is an empty set or whether this will have all the integers. Because the sign of a is not given to us, we will say that this is either empty set or it will contain the set of all integers. In this question, let us assume that a and b are natural numbers such that a square plus ab plus a is equal to 14 and b square plus ab plus b is equal to 28. If you are looking at a square plus ab plus a, this is equal to 14 and b square plus ab plus b is equal to 28. If you are adding both of them together, we are going to get a square plus b square plus 2ab plus a plus b. This is equal to 42. A square plus b square plus 2ab is a plus b whole square plus a plus b is equal to 42. This can be factorized to equal a plus b into a plus b plus 1 is equal to 42. If you assume that a plus b is equal to k, k will also be a natural number such that k into k plus 1 is equal to 42, and because k is a natural number, you will conclude that the value of k will be equal to 6, because 6 into 7 is equal to 42. Now if a plus b is equal to 6, if you are looking at any one of the equations, say you are looking at the first equation, this is a into a plus b plus a is equal to 14. That is the value of a square plus ab plus a. This is 6a plus a is equal to 14, or the value of a is equal to 2 and the value of b is equal to 4. Therefore, the value of 2a plus b will be equal to 4 plus 4, which is equal to 8. So the answer for this question is option A.
Google search Krakow free cat mock. Click on the first link. You can attempt a free mock test which was attempted by 30,000 cat aspirants in the actual exam format. After completing the test, you get detailed solutions, analysis and percentile along with your scorecard to gauge your All India performance. Click on the solution to get video solutions from our expert faculty.
In this question, we are asked to calculate the largest real value of a, for which the equation modulus of x plus a plus modulus of x minus 1 is equal to 2 has an infinite number of solutions for x. Let us first understand how does the graph of modulus of x minus p look like. If you are drawing the y-axis and the x-axis, this is how modulus of x minus p looks like. This is p, this is modulus of x minus p. When x is equal to 0, it will be p, it will keep continue to come downwards, it will reach 0 when the value of x becomes equal to p, and then it will again keep on rising. Or another way to look at it is, to the left of p, the value of the function is p minus x, and to the right of this it is x minus p. That is basically how modulus of x minus p is defined. Now let us try to understand the graph of modulus of x plus a and modulus of x minus 1. If you are drawing the, let us look at it over here. The base for modulus of x plus a will be minus a, and the base for modulus of x minus 1 is 1. So if you are drawing both the graphs, in the first case let us consider minus a to be less than or equal to 1, or a to be greater than or equal to minus 1. In the second case, let us consider minus a to be greater than or equal to 1, or the value of a to be less than or equal to minus 1. In the first case, if you are drawing the graphs, here you have the y-axis and here you have the x-axis. As minus a is less than or equal to 1, the base of modulus of x plus a will be to the left of the base of modulus of x minus 1. So it will look something like this. This is modulus of x minus 1, and this is modulus of x plus a. The reason this is important is because this is when x is equal to minus a and this is when x is equal to 1. To the left of the line x is equal to minus a, this will be equal to minus x minus a. To the right of it, this will be x plus a. Similarly, the graph of modulus of x minus 1, to the left of x is equal to 1, this will be 1 minus x, and to the right it will be x minus 1. This is something that we have already seen. Now if you are adding this line and these lines together, it will look something like this. You will have x-axis, y-axis, you will have a line like this, then you will have a straight line like this, and you will go up like this. This one where x is equal to minus a, and this will be when x is equal to 1. To the left of x is equal to minus a, this will be minus x minus a plus 1 minus x, which will be equal to 1 minus 2x minus a. And in the middle you have x plus a plus 1 minus x, which is basically equal to a plus 1. And to the right over here, this graph will be x minus 1 and this graph is x plus a. So if you are adding both of them together, you are going to get 2x plus a minus 1. Now this will have infinite solutions when this is equaling to only if this line, this straight line over here, a plus 1 is equal to 2, or when a is equal to 1. In the second case, when the graph of x is equal to minus a lies to the right of x is equal to 1, it will be something like this. We have the y-axis, we have the x-axis, we have this line which is x minus 1, modulus of x minus 1, and this line is modulus of x plus a. Over here x is equal to minus a is to the right, this is x is equal to 1. To the left of x is equal to 1, this function will be 1 minus x. To the right, this is x minus 1. Similarly, to the left of x is equal to minus a, this will be minus x minus a, and this will be x plus a. So now if you are adding both of those moduli in one graph, you have the y-axis, you have the x-axis. To the left of x is equal to 1, it will be something like this. Then you have a straight line, and then you again go up. It will be something like this. This will be 1 minus x plus minus x minus a. So this is 1 minus 2x minus a. This will be x minus 1 plus minus x minus a, which is minus 1 minus a. And to the right will be x plus a plus x minus 1, which is 2x plus a minus 1. This function is equal to 2 will have infinite solutions if minus 1 minus a is equal to 2, or the value of a is equal to minus 3. So either a is equal to 1 or a is equal to minus 3. The larger of the two is when a is equal to 1. So the correct answer is option C. In this question, we are told that x, y and z are natural numbers such that xy plus yz is equal to 19 and yz plus xz is equal to 51. We are asked to calculate the minimum possible value of x into y into z. Here we are told that xy plus yz is equal to 19. So if you take y common, y into x plus z is equal to 19. X, y and z are natural numbers. So the minimum possible value of x plus z is 2. This will happen if x and z are equal to 1. This would tell us that the only possible value of y is equal to 1 because the factors of 19 are 1 and 19. If x plus z is at least equal to 2, x plus z cannot be equal to 1. So x plus z has to equal 19 and y will be equal to 1. Now if you look at the second equation, we are told that yz plus xz is equal to 51. Or if you take z common, z into x plus y is equal to 51. Y is already equal to 1, we know that. So z into x plus 1 is equal to 51. What are the factors of 51? The factors of 51 are 1, 3, 17 and 51. So if z is equal to 1, we will have x plus 1 to be equal to 50 or x is equal to 50. But x plus z is equal to 19 is not satisfied, so we will ignore this. If z is equal to 3, x plus 1 is equal to 17 or x is equal to 16 and this is satisfied. So this is one solution. Z is equal to 3 and x is equal to 16. If z is equal to 17, x plus 1 will be equal to 3 and x is equal to 2. Again this equation is satisfied, so this also is valid. Z cannot be equal to 51 because in that case x will be negative. If z is equal to 51, x will be equal to 0, so that's clearly not valid. That won't be a natural number. X plus z will not be equal to 19 and so on. So this equation basically has two solutions. In one solution we have x is equal to 16, z is equal to 3 and y is equal to 1. In the second one, x is equal to 2, z is equal to 17 and y is equal to 1. In the first case, the value of x into y into z is 48. In the second case, the value of x into y into z is equal to 34. So the minimum possible value of x into y into z is 34. So the answer for this question is 34. In this question, we are told that for any real number x, the function where x is given in brackets denotes the largest integer less than or equal to x. We are told that the sum of integer part of 1 by 5 plus n by 5 is equal to 25 for a sum of such functions. We are required to calculate the value of capital N. Before we get worried, let us first note down a few of these numbers and try to find out what their value is. When the value of n is 1, this is 1 by 5 plus 1 by 25, the integer part of it. This will be equal to 0 because this is less than 1. The second term will be 1 by 5 plus 2 by 25. This also will be equal to 0. This will continue to be 0 till the value of the second term is at least equal to 4 by 5. And when does this become equal to 4 by 5? It becomes equal to 4 by 5 when the value of n is equal to 20. So the first time it becomes equal to 1 is when this is 1 by 5 plus 20 by 25. This is equal to 1. The actual value is also equal to 1. Therefore, the integer part of it is also equal to 1. The next term is 1 by 5 plus 21 by 25. This is slightly greater than 1 but definitely less than 2. So this also becomes equal to 1. This continues to be the case and it becomes equal to 2 for the first time when this part n by 25 is equal to 9 by 5. Because then 1 by 5 plus 9 by 5 becomes equal to 2 and the integer part will also be equal to 2. So the value of n will be 45. So when this is 1 by 5 plus 45 by 25, for the first time this is equal to 2. So the last time it is equal to 1 is when the value of n is equal to 44 by 25. Here it is equal to 1. So how many times is it equal to 1? The number of times we get this function to be equal to 1 is 44 minus 20 plus 1, which is equal to 25. So 25 times we are getting this 1 and the sum of the first 25 terms is also equal to 25. So when you are getting this, the value of n has to equal 44, because when the value of capital N is equal to 44, the value is 25. When the value of capital N is equal to 45, the sum becomes equal to 27. This is 25 for the first 25 terms, and then 2 start. We are required to stop when the sum is equal to 25. So the value of n is equal to 44. In this question, we are required to calculate the number of integral solutions for the equation x square minus 10 to the power x square minus 3x minus 10 is equal to 1. If you are given the equation which is of the form a to the power b is equal to 1, there are 3 cases in this. Either a is equal to 1, because 1 to the power anything is equal to 1, or b is equal to 0, that is the exponent is equal to 0, but here we have to ensure that a is not equal to 0. And the third case is that a is equal to minus 1 and b is even, because minus 1 to the power any even number is equal to 1. Let us consider the possibilities for each of the 3 cases in this particular question. If a is equal to 1, then x square minus 10 is equal to 1, or x square is equal to 11. This is not possible because we are only looking for integral solutions. So we'll ignore this. Let us look at the second case where b is equal to 0. That is x square minus 3x minus 10 is equal to 0. X square minus 3x minus 10 can be simplified to equal x minus 5 into x plus 2. This is equal to 0. So the value of x is either equal to 5 or x is equal to minus 2. In both the cases, the value of a, that is x square minus 10, is not equal to 0. So both of them are valid solutions. Let us look at the third case. A is equal to minus 1. That is, we want x square minus 10 to be equal to minus 1. So x square is equal to 9. So either x is equal to 3 or x is equal to minus 3. What is the value of b? That is, the exponent should be an even number. Exponent is x square minus 3x minus 10, which is x minus 5 into x plus 2. When x is equal to 3, this will be 3 minus 5, which is minus 2 into 5, which is an even number. So it is valid. When x is equal to minus 3, this will be minus 3 minus 5, that is minus 8 into minus 1, which also is an even number. So this also is valid. So the number of integral values that x can take are equal to 4. In this question, we are told that f of x is a quadratic polynomial in x such that f of x is greater than or equal to 0 for all real numbers x. So let us write f of x to be equal to a into x minus b whole square plus c. As f of x is greater than or equal to 0, a, which is the coefficient of x square, will be greater than 0. We are told that f of 2 is equal to 0. If f of 2 is equal to 0, 2 is a root of this quadratic equation and c will be equal to 0. So f of x is of the form a into x minus 2 whole square plus 0. And f of 4 is equal to 6. If f of 4 is equal to 6, we can substitute the value of x to be equal to 4. So 6 is equal to a into 2 into 2, 2 square, which is equal to 4a. Or the value of a is equal to 6 by 4, which is equal to 1.5. So the value of f of minus 2 will be equal to a into x minus 2 whole square, which is 1.5 into minus 4 whole square, which is equal to 1.5 into 16, which is equal to 24. So the answer for this question is option B. In this question, we are told that r and c are real numbers, and we are also told that r and minus r are roots of 5x cube plus 6cx square minus 10x plus 9. We are required to calculate the value of c. In a cubic equation which is of the form ax cube plus bx square plus cx plus d is equal to 0, if the three roots are p, q and r, the sum of the roots, that is p plus q plus r, will be equal to minus b by a. The product of the roots taken two at a time, that is pq plus qr plus pr, is equal to c by a, and the product of the roots, that is p into q into r, is equal to minus d by a. If you are assuming that the three roots, because r and minus r are already two of the roots, if the third root is say small p, then the sum of the roots will be r plus minus r plus p. This is equal to p. And using this formula, the sum of the roots p is equal to minus c by 5. Or the third root is minus c by 5. Now the third root will also satisfy this given function, that 5x cube plus cx square minus 10x plus 9 is equal to 0. This would imply that 5 into minus c cube by 125 plus c into c square by 25 minus 10 into minus c by 5 plus 9 is equal to 0. This is minus c cube by 25. This is c cube by 25. So let us cancel both of them, and we are left with 2c plus 9 is equal to 0, or c is equal to minus 9 by 2. So the value of c is option A, which is minus 9 by 2. In this question we are asked, suppose for all integers there are two functions, f of x plus f of x minus 1 is equal to 0, and g of x is equal to x square, and we are also told that f of x square minus x is equal to 5. We are required to calculate the value of f of g of 5 plus g of f of 5. What is f of g of 5? Because g of x is x square. What we are required to calculate is f of 25, because g of 5 will be equal to 25. And g of f of 5, which is f of 5 whole square. So if we calculate f of 25 and f of 5, we will be able to answer this question. We are given that f of x square minus x is equal to 5. So let us assume the value of x to be equal to 0. So f of 0 square minus 0 is 0. So f of 0 is equal to 5. What is the value of f of 1? You can use f of 1 plus f of 0 is equal to 1. This is again from the equation that is given to us. We know f of 0 is equal to 5. So f of 1 will be equal to minus 4. What is f of 2? F of 2 again will be, because f of 2 plus f of 1 is equal to 1. F of 2 will therefore be equal to 5. Another way of looking at it is that f of x plus f of x minus 1 is equal to 1. This is true for all values of x. So if you substitute the value of f of 0, f of x to be equal to 1, f of 0 plus f of 1 is equal to 1, which is equal to f of 1 plus f of 2, which is equal to f of 2 plus f of 3, and so on. If you are looking at this equation, you will figure out that f of 0 is equal to f of 2 and will be equal to f of 4, and so on. If you are looking at this equation, you will figure out that f of 1 is equal to f of 3 is equal to f of 5, and so on. Now we know that f of 0 is equal to 5. So all of the even numbers, the value of f of x will be equal to 5. And we know that f of 1 is equal to minus 4. So the value of all the odd numbers, if x is an odd number, f of x is equal to minus 4. So f of 25 will be minus 4. And f of 5 is also equal to minus 4. So the required sum will be minus 4 plus 4 square, which is equal to minus 4 plus 16, which is equal to 12. So the answer for this question is 12. In this question, we are told that there is an exam in which there are 75 questions. Some of the questions are correct, some of the questions are wrong, and some of the questions are unattempted. If a person gets a question correct, he gets plus 3. If he gets a question wrong, he gets minus 1. And if he doesn't attempt the question, he gets plus 1. So the total marks that is scored will be 3C minus W plus U. This we are told is equal to 97. And because the total number of questions is equal to 75, C plus W plus U is equal to 75. If we are also given that the number of unattempted questions, that is U, is greater than the number of attempted questions. So U is greater than C plus W. We are asked to calculate the maximum number of correct answers, that is C max is equal to what? This is what we are required to calculate. When you are given two equations, if one of them has minus W and the other one has plus W, let us first add both of them so that we can eliminate one variable, which is W. If you are adding both of them, you are going to get that 4C plus 2W, sorry, 4C plus 2U is equal to 172 or 2c plus u is equal to 86. Now before we calculate the maximum possible value of c, in this case we have to minimize the value of u. If we can minimize the value of u, then we will maximize the value of c, because 2c plus u is a constant which is equal to 86. What is the minimum possible value of u? There is a condition that the number of unattempted questions is greater than the number of attempted questions, that is u is greater than c plus w. So here we will do a simple trick. To both sides of this inequality we will add plus u. So 2u is greater than u plus c plus w. But what is the value of u plus c plus w? That is a constant which is equal to 75. So u is greater than 37.5. Because we are looking only for integers, the minimum value of u is equal to 38. So u minimum is 38, in which case c is maximized. That will be equal to 86 minus 38 divided by 2, which will be equal to 48 divided by 2, that is 24. And in this particular case, w also can be calculated. That will be 75 minus 38 minus 24, that is 7. This will be 13. So just to confirm, from the unattempted questions is going to get plus 38. From the 24 correct questions is going to get plus 72. And from the 13 wrong questions is going to get minus 13. So his total score will be 97. Anyway, the answer for this question is 24. The maximum number of correct questions you can get is 24. In this question, we are asked to calculate the number of distinct integer values of n, for which the inequality 4 minus log n to the base 2 divided by 3 minus log n to the base 4 is less than 0. Let us assume that the value of log of n to the base 4 is equal to p. What is log of n to the base 4? This is equal to log of n to the base 2 square, which is equal to half of log of n to the base 2. So then log of this will be equal to p. So log of n to the base 2 will be equal to 2p. So the inequality that is given to us is that 4 minus 2p divided by 3 minus p is less than 0, or 2 minus p divided by 3 minus p is less than 0. We can multiply the left hand side and right hand side with 3 minus p whole square just to remove the denominator, and we will be left with 2 minus p into 3 minus p is less than 0, or the value of p belongs to 2 and 3. But what is p? P is log of n to the base 4. So the value of n will belong to 4 to the power 2 and 4 to the power 3. 4 to the power 2 is 16, 4 to the power 3 is 64. It cannot equal either one of these two, because first of all we have a strict less than symbol, and if it is equal to 64 the denominator will be 0. So for multiple case reasons it cannot equal either 16 or 64. So what are the values that n can take? It will be either 17 or 18 or 19 or dot 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 till 63. How many such values exist? That will be 63 minus 17 plus 1. 63 minus 17 plus 1 will be equal to 47. So the number of distinct integer values that n can take is equal to 47. In this question, we are told that c is equal to 16 into x by y plus 49 into y by x for some non-zero real numbers x and y. Then c cannot take the value of. That is what we are required to calculate. Let us assume that x by y is equal to a variable called t. So the value of c is equal to 16t plus 49 divided by t, because y by x will be 1 by t. Now let us consider two cases. Let us first consider the case where t is greater than 0. If t is greater than 0, we can use the arithmetic mean is greater than or equal to geometric mean on the right hand side. So 16t plus 49 by t divided by 2 is greater than or equal to the square root of 16t into 49 by t, that is 16 into 49. Square root of 16 is 4, square root of 49 is 7. So this is equal to 28, or 16t plus 49 by t is greater than or equal to 56. This is when t is greater than 0. Similarly, when t is less than 0, just to make things easier, let us assume that t is equal to minus p for some number p. So p will be greater than 0, and the value of c is equal to minus 16p minus 49 by p, or the value of minus c is equal to 16p plus 49 by p. Like in the earlier case, here we have p to be greater than 0, so minus c will be greater than or equal to 56. If you multiply the inequality with minus 1, because it is a negative number, the sign of the inequality will change, so c is less than or equal to minus 56. So this would imply that the values that c can take, if this is the number series, we have minus 56 over here and we have plus 56 over here. C can take any number from 56 to infinity. C can also take any number from minus infinity to minus 56, but C cannot take the numbers in between. So C cannot be any number between minus 56 and plus 56. The only option which is satisfying that is minus 50. That lies between minus 56 and 56, so that cannot be the value of the given expression C.
We at Krakow provide all the previous year CAT papers along with many other MBA examinations such as IIFT, ZAT, SNAP, MAT, CMAT, TIS and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.
Now suppose k is an integer such that the equation 2x square plus kx plus 5 has no real roots. If you have a quadratic equation which is of the form ax square plus bx plus c is equal to 0, this equation has no real roots if the discriminant is less than 0. What is the discriminant of this quadratic equation? The discriminant is equal to b square minus 4ac, the discriminant d. So if d is less than 0, this will have no real roots. If d is equal to 0, then the roots will be real and equal, or essentially it will have one real root. If d is greater than 0, it will have two distinct real roots. In this particular case, we are told that 2x square plus kx plus 5 has no real roots, that is the discriminant is less than 0. That would imply that k square minus 4 into 2 into 5 is less than 0, or k square is less than 40. If k square is less than 40 and k is an integer, what are the values that k can take? K will be either minus 6 or minus 5 or minus 4 or minus 3 or minus 2 or minus 1, or it will be 0, or it will be 6 or 5 or 4 or 3 or 2 or 1. We are also told that the second equation x square plus k minus 5x plus 1 has two distinct real roots, that is the third case. Here the discriminant is greater than 0. So k minus 5 whole square is greater than 4. This can be simplified. This will be k square minus 10x plus 25 is greater than 4, or k square minus 10x plus 21 is greater than 0, or this is k minus 7 into k minus 3 is greater than 0. So either k is less than 3 or k is greater than 7. Which of these values satisfies k either being less than 3 or k being greater than 7? These four values don't satisfy it, because they lie between 3 and 7. The values which satisfy it are 1, 2, 0 and minus 6, minus 5, minus 4, minus 3, minus 2 and minus 1. So the total number of such values is 6 plus 1 plus 2, which is 9. That is option A. In this question we are told that there is a quadratic equation ax square plus bx plus c, and one of the roots is 3 plus 2 root 2. If a, b and c are integers and one of the roots is 3 plus 2 root 2, it would imply that the other root has to be the complement of 3 plus 2 root 2, which is 3 minus 2 root 2. So the two roots of ax square plus bx plus c will be 3 plus 2 root 2 and 3 minus 2 root 2. What is the sum of these two roots? What is the sum of 3 plus 2 root 2 and 3 minus 2 root 2? That is 6. And what is the product of 3 plus 2 root 2 and 3 minus 2 root 2? 3 plus 2 root 2 into 3 minus 2 root 2. This is 3 square. This is of the form a plus b into a minus b. So this is 3 square minus 2 root 2 whole square. What is 2 root 2 whole square? This is equal to 9 minus 8, which is equal to 1. We know that in a quadratic equation which is of the form ax square plus bx plus c, the sum of the roots is equal to minus b by a. and the product of the roots is equal to c by a. So what this tells us is that c is equal to a and b is equal to minus 6a. Similarly, we are told that 4 plus 2 root 3 is a root of the equation ay square plus my plus n. Again, a, m and n are integers. This would imply that the other root has to be 4 minus 2 root 3. And what is the sum of 4 plus 2 root 3 and 4 minus 2 root 3? This is equal to 8. And what is the product of 4 plus 2 root 3 and 4 minus 2 root 3? This is again of the form a plus b into a minus b. So this is 4 square minus 2 root 3 whole square. This is equal to 16 minus 12, which is equal to 4. So this would imply that minus y by a is equal to 8 and n by a is equal to 4. Or the value of n is equal to 4a and the value of y is equal to minus 8a. So we have the values of each one of them in terms of a. We will calculate the value of b by m. What is b by m? B by m will be minus, this is 8 is actually equal to minus m by a. Y is basically the variable. So the value of m is equal to minus 8a. So the value of b by m will be 6 by 8 and the value of c is a minus 2b is plus 12a divided by n is 4a. This is 3 by 4 plus 13 by 4, which is equal to 16 by 4, which is equal to 4. So the required value or the required answer is option D, which is 4. In this question, we are told that r is a real number such that f of x is equal to 2x minus r if x is greater than or equal to r, and it is equal to r if x is less than r. We are given the equation that f of x is equal to f of x, and this holds for all real values of x where x belongs to a particular interval. We are required to calculate that interval. If you are first trying to figure out how f of x looks like, the simplest way to get an intuitive understanding is by drawing a graph. This is the y-axis and this is the x-axis. And let us assume that r is somewhere over here. Now if x is less than r, it will be equal to r. So it will look something like this. This will also be equal to r. This is equal to r. So as long as x is less than r, it is equal to r. But once x starts going above r, then it becomes 2x minus r, which will essentially be equal to something like this. The slope of this line will be 2. Now you will notice that f of x is always greater than or equal to r. You will not find a value of x where f of x is less than r. This is one understanding that you should have. Now if you are considering f of x, from the definition this is equal to 2 into f of x minus r if f of x is greater than or equal to r, and it is equal to r if f of x is less than r. This is from the definition of f of x. Instead of x, we are substituting f of x. So f of x will be 2 into f of x minus r if f of x is greater than or equal to r, or it will be r if f of x is less than r. But like we have always, like we have just seen, f of x is always greater than or equal to r. So this case doesn't exist. You won't find a value of x such that f of x is less than r. So f of x is always equal to 2 times f of x minus r. If f of x is equal to f of x, that would imply that 2 times f of x minus r is equal to f of x, or the value of f of x is equal to r. Now what are the values of x for which f of x is equal to r? F of x is equal to r if x is less than r, and if x is greater than or equal to r, if you substitute 2x minus r to be equal to r, you will get the value that x is equal to r. So again, x is either equal to r or x is less than r. So the value of x has to be less than or equal to r. So the correct answer is option B. In this question, we are asked to calculate the minimum possible value of x square minus 6x plus 10 divided by 3 minus 6. We are told that x is less than 3. As x is less than 3, let the value of p be equal to 3 minus 6. There are a couple of reasons for this. First, 3 minus x is the denominator of the expression. Second, we are told that x is less than 3. So 3 minus x, which is p, will be greater than 0 because x is less than 3. Now the given expression is x square minus 6x plus 10 divided by 3 minus x, which is p. What is x square minus 6x plus 10? If you look at x square minus 6x, you will notice that x minus 3 whole square is equal to x square minus 6x plus 9. So this expression basically is x minus 3 whole square plus 1 divided by 3 minus x, which is equal to p. But if 3 minus x is equal to p, x minus 3 whole square is equal to p square. So this is equal to p square plus 1 divided by p, which is equal to p plus 1 by p. Now what is the value of p plus 1 by p? The minimum value of p plus 1 by p when p is greater than 0 will be equal to 2. There are many ways you can prove this. Because p and 1 by p, both of them will be greater than 0, you can use the arithmetic mean is greater than or equal to geometric mean. So p plus 1 by p divided by 2 is greater than or equal to the square root of their product, which is p into 1 by p, which is 1. So p plus 1 by p is always greater than or equal to 2 when p is greater than 0. And the minimum value is 2, which occurs when p is equal to 1 by p is equal to 1. The answer for this question therefore is option B, which is 2. In this question, we are told that there is a donation box which can receive only checks of 100, 250 and 500 rupee notes. On a good day, it received exactly 100 checks which total to 15,250. We are required to calculate the maximum number of 500 rupee checks that it has received. Let us assume that it received A checks of rupees 100, B checks of rupees 250 and C checks of 500. So the total number of checks it received is 100. So the value of A plus B plus C is equal to 100. And the value of each of these checks will be 100A plus 250B plus 500C. This we are told is 15,250. This is the information that is given to us. What we are required to calculate is the maximum value of C. To calculate the maximum value of C, let us first eliminate either A or B and try to express C in terms of the remaining variable and try to maximize it. Here it is easy to eliminate A because we can multiply the first equation with 100. So 100A plus 100B plus 100C is equal to 100 into 100, which is 10,000. Now if you subtract the second equation from the first equation, 150B plus 400C is equal to 5,250. We can cancel 1 0 everywhere. So 15B plus 40C is equal to 525, or 3B plus 8C is equal to 105. Here what is the maximum possible value of C? You know that 8C has to be less than 105. So let us look at the multiples of 8 which are less than 105. The largest multiple is 104. So if C is equal to 13, 8C will be equal to 104 and the value of 3B will be equal to 1. But in this particular case, B is not an integer. We want A, B and C, all of them should be whole numbers. That is, they should be greater than or equal to 0 and they should be integers. They can't be 1 by 3. So C cannot be equal to 13. What is the next highest possible multiple of 8? That is 96. In that case, C is equal to 12 and 8C is equal to 96. In which case 3B will be 105 minus 96, which is equal to 9, or B is equal to 3. This seems to be valid. We can also calculate the value of A because A plus B plus C is equal to 100 and the value of A will be 100 minus 12 minus 3, which is equal to 85. All of them are whole numbers, so all of them are valid and the maximum possible value of C is 12.